computer networking, and I have always used that book for teaching this course. And the author is S.K. Shah by S.K. Shah. And more importantly, we will be, as I mentioned, that uh, this course is more about some research aspects as well. So we will be having article reads from Elsevier, Elsevier, okay, the same Elsevier, JNCA, JNCA Journal of Network and Computer Applications. This is impact factor 3.13, and this is impact factor 5.37 kind of thing. So I have publications in both of these journals, and also the famous IEEE transactions on networking. So these are the journals in which I would like you to read articles related to the computer networks and traffic theory. So if I talk most of the let me talk of more on the content side. So on the content side, so although this course is content side, let I will try to make a content wise in a block diagram approach. So it's not about physical uh, topology of computer networks. So we are not going to do this. We are not concerned about routing, uh, other things. So this course is more about traffic. Traffic. It's more about internet traffic. And when we say traffic, then it comes in three aspects, or in two layers. If we talk of network layer, then the traffic is only IP. And in case of transport layer, in case of transport layer, we can categorize as TCP segment and UTP segment, although both of these use IP as a carrier. So this is the main thing. So understanding of the traffic properties, or this is the main thing. We are not going to study any protocol here. Then the thing is that we are not going to study the header of TCP, or how TCP works, or what's the protocol mechanism behind TCP. We are not going to study the protocol header of UTP. Neither we are going to study the protocol header of IP. Uh, but the way that traffic behaves, that's more important. So when we talk of traffic, then the content should be something like that. What are the hidden correlations in the traffic? Hidden correlations. Okay, and how to identify. So these are the one of the main things in your course. And the main thing is that we have to develop models for internet traffic. We have to develop models for internet traffic. So this is the main thing, that without developing models for internet traffic, you cannot understand the behavior of the internet traffic. And these, you know, that once the model for internet traffic is ready, then these models can help you in many different dimensions. And I would like you, or some of you who are more practitioners in computer networks, can you tell me the significance of these models? Okay, what are the current significance of internet traffic models? I mean, practitioners do not, sorry, traffic spelling is traffic. Practitioners normally do not depend on models. But if I give you a model of a traffic, and obviously, what can a model do? Simply, I can write that a model can mimic network traffic. It can mimic the stochastic properties of network traffic. It can generate network traffic. It can generate network traffic. Okay, so that's the reason. So can anybody tell me that now I have elaborated the what a model of internet traffic does. So what can be it useful in different ways? If I have a model for internet traffic, although saying is easy, doing is difficult. You might have seen my research publications and other papers which I am keep sharing. I will share more articles that developing for model for an internet traffic is not easy, because internet traffic is the main challenge is that internet traffic is totally uncontrolled. There is no governance there. There is no kind of uniformity in internet traffic. It behaves differently in access networks. It behaves differently in backbone core networks. It even behaves differently from media to media. Okay, so I would like some of the comments that how can internet traffic modeling help you. So coming back, uh, my question to you is that that internet traffic model. So this is the question. I would like for your feedback. Uses or limitations. Okay, uses and limitations. And I want you all to help me to fill this table. You all know, if you want to repeat what a traffic model does, you can see that it mimics network traffic. It can generate network traffic. I mean, it 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 explains or it mimics the stochastic properties of network traffic, and then it can generate a real kind of traffic. So coming back to here, so I hope the slide is clear. What I'm writing is clear. So I need your help in identifying the uses and limitations of internet traffic. So come on, you should think on this and give me some pointers and help me there.
Sir, one definite use would be the future capacity planning.
Okay, that's very good. That internet traffic modeling can help in. What's your name? What was your name?
Sir, it was Junaid Iqbal.
Junaid, thank you very much. Capacity planning, okay? And capacity planning, Junaid, can you, for our other fellows, can you explain the meaning of capacity planning?
So capacity planning means that we have to forecast the traffic, the future traffic that we are going to handle. Like
Hmm.
in the access layer and the core layer, we uh, use the net flow technique with the
Hmm.
Cisco routers as well to identify the top
Hmm.
talkers. So this is something like stochastic model would definitely help in
Hmm.
forecasting the future traffic.
That's good. So I think the second point you mentioned as a part of capacity planning, although capacity planning is a very a specific word, but you have mentioned a very important word, Junaid, that forecasting, traffic forecasting. Because if you are able to forecast your future demand, you can ask from your providers or your customers. If you are a provider, then you can do for customers that you can do forecasting and then plan accordingly. So forecasting actually, what I would say that it helps in capacity planning. So it's a kind of component which helps in capacity planning. There are different models. Let me tell you that there are internet if because the target here is to understand the uses of internet traffic modeling exercise. My entire PhD was based on internet traffic modeling. I can speak a lot on this, but obviously I will have to stay on my course here. But internet traffic modeling, the models, some of the models, they have the capability to forecast, and most of the models, I tell you, Junaid, they do not have the ability to forecast. So forecasting is something, I am adding a remark here. This is something very challenging. Okay, as not all internet traffic models are able to forecast traffic, and there are some reasons as well which we discussed later. So again, thank you very much. Any other point that how internet traffic model will be useful for the services? Because think from the point of view for services, because
Yes.
internet traffic flows through networks. It you can talk whatever you think. Be creative, because internet traffic, I'm speaking from my endpoint, which is a laptop by HP. It's going from my cable net operator, and then it's going to some public internet gateway, and then going outside on the public internet to Zoo to Google Meet server, and then coming back to you in the same similar fashion. So in this way, how an operator or user will see the significance of a traffic model.
Sir, it can help in bandwidth management.
Bandwidth management,
Sir,
BW.
it is also useful in designing different traffic monitoring applications for vendors.
Okay, again, capacity planning also, bandwidth management also helps in capacity planning, I would say. So the other point you mentioned that it's helping vendors in what?
Different traffic monitoring application designing. में.
You mentioned that what I would write is that traf or monitoring
Designing different traffic monitoring applications.
monitoring applications.
अस्सलाम वालेकुम सर,
Walaikum salam.
क्या हाल है सर? सर बेहतर है अभी
Monitoring
तो
application.
काफ़ी
Okay.
कंजेशन वगैरह कम है। नहीं सर, वो मेरी सिस्टर अभी कोविड में ही थी ना, तो उनकी अब
Okay.
सारी डायरेक्शन फॉलो कर रहे हैं। तो उन्होंने फ़िलहाल तो नहीं कहा कि किसी टेस्ट को यूज़ करें, बट उन्होंने पूरे एक टाइम टेबल भेज दिया है आवरली बेसिस के ऊपर कि क्या क्या किस तरफ कब करना
Okay.
है, और डाइट में स्टीम और ये वो सारे कुछ। तो अभी वो उसी को रिलीजियसली फॉलो कर रहे हैं, तो उससे काफ़ी। जी सर था, मगर कल अम्मी की तबीयत ऐसी नहीं थी ना कि मैं उनको
You
बिठा
can
के
mute
और
him. His mic was
बैठाता।
open.
वो भी लेटी
So
हुई थी
Acha,
आराम में, तो
okay,
मैंने कहा
okay,
मैं
okay.
डिस्टर्ब
I
नहीं कर रहा
think we
उनको।
need to mute him.
तो
Sorry. I think
जी जी
someone's mic is open. And Danish?
जी 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 एस्ट्रॉयड के लिए सर उन्होंने भी रखा हुआ है ऑप्शन लास्ट में। वो कह रही हैं कि अगर, हाँ मैं वो कह रही
Unfortunately, I have to kick out Danish from the meeting because his cell phone was open and he joined and just left. So Danish will join later on. So please make sure that if you're open, then you should concentrate on the class. And you see that the entire class was disrupted. So coming back to this, okay. So can you this the screen here again?
Yes,
Is
sir.
the screen
Yes,
visible?
sir.
Yes,
Okay,
yes,
so
yes.
monitoring applications. I agree that internet traffic model can help in designing monitoring applications, and it can limit down the scope of the monitoring applications. Okay, what else uses
Sir, preempt any real-time failure of network
real time?
failure. We can preempt through models any real-time failure of the network.
I think this your remark, because you mentioned that it's an internet traffic model can help in modeling real time failure. I think this remark is related to internet traffic, but it's what is the cause of the failure? Can you justify that? Is traffic cause of the failure? Because what I believe that your remark is more relevant to the internet topology. Topology is a different thing. It's something related to the what I would say that your remark will be more applicable when we graph theory to model computer networks. That's also one of the topics here but that's more limited to the scope of the internet traffic, internet topology design. In this case, internet traffic modeling is something which is more universal exercise. I mean, the idea here is that to develop internet traffic model which can mimic the stochastic behavior of the internet traffic, whether it flows from access network, core networks, topological aspects, and it's more covered in graph theory. So we will discuss in more like in graph theory, because that failures of the network or kind of thing I don't think that internet traffic is responsible for network failure. Some kind of link failure can be attributed to power issues or some fiber cuts or kind of thing. Mm, I think that what you should call as, I think, if you allow me to rephrase your word, I can call it as a congestion management. So will you agree with me?
Yes, sir.
Okay, so just it's just matter of rephrasing. So we will not use any word which is more like related to the kind of topological aspects. We just concerned with the traffic thing, more universal kind of thing, and other uses. I think we should. And any other comment on uses of internet
Yes.
traffic modeling?
So
Sir,
designing and upgrading new protocols.
Again, internet traffic uh, modeling of internet traffic, that will depend upon the protocol dependent modeling. And you are right that traffic modeling can help us when new protocols are needed. So I think that what I should write it that when protocol upgrade or when protocol upgrade is needed. Sorry that there's too much noise at my home, so we have to bear with this. So so and I think one of the key things which nobody mentioned is till now is
Their quality of service.
yes, very good. That's quality of service. That's the two there were two main things in my mind. I think that one, Muna mentioned that it's
Uh,
quality of service. That's great. Okay, that you cannot
To have
ensure
a
quality of
high
service that,
speed network,
sorry.
to have a high speed network.
Obviously quality of service means that you have to, it's not about what I mentioned, that we should not talk of network and its properties. We have to talk about traffic and its properties. We have to assume that we have to assume network independency at the moment. Network can be high speed, network can be low speed. In any case, we have to ensure quality of service. And while studying on, while designing, normally those of you who are designers, they understand that while designing they always consider the worst case, which is the low speed network. So we have to ensure quality, because in case of high speed network, there's always no packet loss. In case of high speed network, there is no jitter, there is no latency. So the concept of quality of service remains marginal there. There's no importance. But in case of the network which is highly congested, which has so many users, which has bandwidth limitations, which has so much filtering involved going in there, because various governments like China and other government, they have so much filtering, content filtering involved. So in this case, ensuring quality of service is a challenge. Okay, so quality of service, so matter of high speed network and low speed network is, I think that's already covered in point number one. That's about capacity planning. Okay, so Mona mentioned one important point, quality of service, and I will also add here quality of experience, which is can anybody tell me the difference between quality of service and quality of experience?
Sir, the quality of service is that which is being sent from the service provider, and the quality of experience is that is received from a user experience point of view.
Yes, that's great. Quality of service is a metric which is used by operators, and quality of experience is a metric which is used by users of your service. So, and sometimes their goals are contradictory. You cannot ensure quality of service and quality of experience together at a time. Thank you very much. And one of the important traffic modeling goals, which I was expecting that you guys will speak first, is about security. How can internet traffic model can help in security? Any comment, please? How can internet traffic model help in security?
yes, sir, we can observe different network attacks like denial of service attacks and many kind of different attacks.
Hmm.
So we can identify that traffic. Also, the queue hit, queue can be hit this also means that the network device management is also one use of this internet traffic model.
Yes, I agree with your comment. Uh,
Sir,
can you? Okay. So the main thing is that how a model can be useful for internet traffic modeling. I think if you this comment, I would like you to have a more discussion, and I would request you all to. I will stop sharing the here, and I would all. I hope every one of you has a laptop here. Uh, Let me share an article here. Name. So, have you got this link? I have shared a link on a chat window.
Yes, sir.
Yeah, yes, sir, got it.
So just open the link and read. It's in my article in one of the top journals of computer network. It's Elsevier JNCA. Just read the abstract, and because you might not have access to the full article, but you might just read it. And meanwhile, I share the full article here. So I give you 5 minutes to read. Just go through, browse through this article. And meanwhile, I try to. And I think that I have already shared in the class stream.
Yes, sir,
Yes,
you did.
yes, yes. So you can open the PDF file. I've already shared this on the class stream. So just open that paper, and so that paper is more about. You see that paper has proposed a traffic model for internet traffic, like it has proposed. Uh, Let me open my video. I hope I am clear now. Mm. So that paper is has proposed a model for internet traffic, and that's about Weibull distribution, and that's more about what we call as IID, independent and identically distributed data. And you can have so many distributions like Poisson distribution, Weibull distribution, Pareto distribution, in stats or applied probability. You might have studied so many distributions. So in this article, I presented an extensive analysis, and if you read through my article, you will find an important factor. Just browse through that article, because most of the guys here in the start of the class, they were mentioning of the topology, because there were concerns that I agree that your concerns can be right, that ignoring topological aspects can be unrealistic. So and also the physical layer should not be ignored. So if you can see that, read the paper. I have analyzed traffic from DSL network. I have analyze traffic from wireless hotspot network and Ethernet network. Okay, so it's Ethernet network, and also the unique thing which distinguish my paper from all of the other articles, because this article is one of the first paper in which I analyze three different access network: DSL network, wireless hotspot network, and Ethernet network. And it was the traffic captured from the one of the largest cities of New Zealand, urban cities, from Auckland. So so ISP name, due to research, we have an MOU that we are not allowed to disclose the name of the ISP. But when I have said that it's the largest ISP of the Auckland, so you can all guess what I mean. Okay, and then you can also see that I also analyzed the traffic at the multiplexing point. I write it as multi fixing point at the core gateway. So and I propose and I assess traffic at DSL network, wireless hotspot network, and Ethernet network, and when the traffic multiplexes together on a router. So and then it gets to the public internet and then revert back. And this the traffic I analyzed. And another unique thing which I analyzed in this paper is that I completely differentiated between incoming traffic and outgoing traffic. And furthermore, I modeled traffic at packet level, I modeled traffic at flow level, and I modeled traffic at session level. So the complete, so this article is quite much relevant to your course, and we might be coming back to this article later on. So I would like to read this article. But coming back to the main question, I don't want you to all to read this article, how I propose label distribution, and how you know that when you submit an article to such kind of journals, it's not easy to publish in there. It takes whole year to publish in there. Sometimes it goes unsubmitted state, sometimes review state. So and you can see that when was article received. And there's also a period before article received time, which where I worked here for the research project. So reviewers ask so many questions, you have to justify each and every point. You have to the paper went through, I think, 5 to 6 rounds of major revision, and then it got accepted. And I also got invitation to speak about in a conference for this paper, because this is one of the good paper which has been cited extensively. So how this paper can help in security?
Sir, by analyzing packet flow and sessions.
No, because no, just see the paper title. What's the paper title?
To speak to the designated router.
Yes, what is the paper title? What is the paper title?
The role of Weibull distribution in internet backbone and core networks.
Okay, okay. Mm, mm, Kashif? Okay, there was some guy who was speaking. So if you can see that the title is the role of Weibull distribution in modeling traffic in internet access and backbone core networks. So it says the Weibull distribution. So what about if the traffic is not Weibull? What it does mean? See what the title is suggesting. The title is suggesting that internet traffic is modeled by Weibull distribution. And I see some chat comments saying that because flow was never analyzed or not possible. Yes, this kind of things are possible, but at the moment I am talking more about that what's the internet traffic modeling. So if I say that Weibull distribution is a best fit for internet traffic, and it mimics the behavior of internet traffic, you can see that although it's a big claim, this paper is a very surprising paper for all of the researchers in the internet community, because I proposed that in a unified framework of access and backbone core network. You can see in the results of the article, I have separate columns here: DSL network, Ethernet network, and other if and ISP core network. So I have analyzed the traffic in much detail in both directions, and proved that Weibull distribution based on the shape parameter value, it models internet traffic. So how I did that research is not about, I'm not asking this, I will explain you later on. But at the moment, if I'm saying, or if somebody says that the Weibull distribution fits well to the internet traffic. So what do you mean? It means that a normal internet traffic behaves like a Weibull distribution, or like any distribution like Weibull. It can generate random variables. Internet traffic is random, you all know that, because it's a random phenomena. So the Weibull distribution also generates thank you, Junaid, for your remarks. It's not commendable work, it's just hard work. Sometimes hard work beats talent. I am not very talented guy. I just did hard work to prove that and it's so it means that I'm proposing that the normal internet traffic behaves like a uh, variable distribution. Its parameters, its inter-arrival times, its count data. Because most of the thing when we talk of this course, we will talking more about packet inter-arrival times. We will talking of flow inter-arrival times. We will be talking of session inter-arrival times, and we will also talking of packet count data, flow count data, and session count data. So all of these things will be modeled by variable distribution of what? Of normal traffic. And uh, why I'm saying that this modeling exercise, or my proposal for my internet traffic model is useful in internet security. Because if an internet traffic while capturing internet traffic, because you capture internet traffic, and you match the parameters, you evaluate the parameters, and you check the fitness, because there are so many fitness algorithms. We will uh, um, we will talk of fitness algorithm. The when as soon as internet traffic starts deviating from variable distribution, that's a danger sign. That's a danger, because the traffic is behaving other than what is supposed to be expected. If it's matching variable distribution, it means that it's normal traffic. And if it's not matching variable distribution, then it's an indicator of anomaly. So I will show you a paper in which a paper titled as anomaly detection method for internet traffic. And those guys cited my paper, and then they wrote another paper in which what they assessed, that deviation from variable distribution is an indicator of traffic anomaly. I repeat, Bilal is saying that what exactly is variable distribution? Can you please elaborate a little? Don't worry about this. Variable distribution is just a distribution in stats, just like exponential distribution, just like Pareto distribution, which is used to generate random variables. Okay, I hope Bilal, you got my answer. Variable distribution is a distribution which can generate random variables as per the distribution. Okay, and what is the distribution? Obviously, distribution is generate random variable as per a specified mean, variance. There are so many distribution statistics, and there are different parameters. Some distribution has low variance. Some distribution generate data with high variance. Some distribution data generate which is spread. And some distributions like normal distributions or Gaussian distribution, they have both sides. Uh, um, um, it's more like a bell curve. So it's more like, just like what I know that in various uh, I would elaborate Bilal's query by saying that in Bahria University and other universities, my colleague teachers were saying that marks should be awarded in such a manner to a class that they fit like a Gaussian distribution or bell curve. Though normally they call it the bell curve. There should be average marks and some extreme marks. So this is the mark distribution in our private universities, that just to meet Pakistan Engineering Council criteria. So just the way I give you marks, okay, that's also can be I give full marks to all students. Or I give, I for example, Bilal, Junaid, Omer, Tarek, and other Muna, they are all students. I give the final exam, you all get 70 marks out of 100. So what is the distribution? If all of the students in this class get the same mark, so what will be the name of this distribution?
So linear.
Linear? No, no, not linear, because linear increases, linear decreases. There is that trend in there. There's no trend. There's no trend. So this is
Dot.
it's a uniform distribution. It's a uniform distribution. But if I give uh, I give I give very low marks to most of the students. I give very low marks to most of them, and two and three students I give very high marks. Okay, so if I give very low marks to uh, if there are 34 students in this class, so 30 students I give very low marks, or in around a certain parameter, and four students I give very high marks. So what will be the distribution? It's called as Pareto, or if you don't know Pareto, then just remember extreme value distribution. Extreme value distribution, because I'm extreme, because my behavior is extreme. I'm generating extreme behavior. Most of the students I'm giving an average marking around a certain parameter, and then few students I get very high marks. So this is extreme behavior. So the distribution controls the spread of data. So I hope, Bilal, my you got the answer. So Weibull distribution is a distribution which can be used to model certain trend of the data or how it generates the data. So it has the beauty of Weibull distribution is that the parameters are controlled, and it can control mean, variance, and other higher moments. So that's why the Weibull distribution works well. So again, we will talk mathematically. We will talk in Karachi, the weather distribution, how weather behaves. It can be modeled by a distribution. In northern parts of Pakistan or in Yemen, Amona, what's the distribution in Yemen? Weather distribution. It is extreme weathers, or just the weather in Yemen remains around a certain average value.
I don't know exactly.
Because I'm asking you the question that Yemen, there's a temperature distribution. So I'm asking the temperature distribution, that in Yemen the weather is currently in summer it's around
That, yeah,
27
yeah.
degree.
In summer is very hot in my city, and in winter, not like Karachi, is
It's
is
very cold.
no, no, no. In the north is very cold, but in the south is not cold.
So I mean, are you saying that and that temperature data distribution in Yemen is not very extreme?
Mm.
So you should think on that by the end of this course, you should be able to model the temperature values in Yemen. So this will help you a lot. So that's why this course, the stochastic process course, if you understand correctly, that can help you in many different ways. Earthquake engineering and other climatic guys, they all can understand from this applied statistics. I'm getting various queries from our PhD students to attend this course, but we have already 40 students in this course, so I have denied their request, and I will teach them in a different class. So believe me, you should understand the distribution of the data. And the Bilal's query was that, because I think it was my mistake to start abruptly and I start talking of the Weibull distribution. So first I should have illustrate what is a distribution. So I will illustrate more mathematically later on how to define its distribution. Can anybody tell me how to formulate a distribution? Because just want to check a background, because you, the NAD guys here or other of the fellows in your undergraduate, you might have studied some distributions. So can you tell me how to write a distribution, and what the graph of distribution is called as, what you call as the graph? I have written a word in your chat window. Mona, have you studied this thing?
Sorry?
Like, I have written a word in chat window.
Yeah, yeah.
Can you read it?
Probability density function.
Have you studied this thing before?
No.
Okay, so I have to illustrate these things. So that's more about uh, the behavior of random variables or random values like temperature or traffic values. So a density function just illustrates how the data behaves, For example, if a density function, I will draw a diagram that in which you will, I will illustrate how density function behaves. But meanwhile, I just wanted to illustrate that, I repeat that a distribution of a data, it explains you how the data is coverage. How are the data centered around mean value? Are there extreme values in the data, or are there very little chance of extreme values in your data? For example, what is the chance of -20 in Yemen? Is it a chance of minus 20 degree in Yemen?
No, no, no.
No. Okay. Is it a chance of 0 degree in Yemen? In Yemen.
Yes.
Okay. So that's why. So and similarly, so is it a chance of 10 degree in Yemen in winter?
Yeah, yeah.
So you can see that. So based on this behavior, the likelihood. So the distribution defines a likelihood function to data values. So think of that there are data values 1, 2, 3, 4, 5, 6, 7, 8, and each of this is a temperature. It's going starting from 1 and it's going to 100, 1000, 2000, 1 million. So a distribution assigns the likelihood. Okay, the distribution assigns the likelihood that what values are more likely. uh, just to be more to just to be I show you the screen here because the question was interesting and you all know this.
Sir, we can say that the distribution shows us the possible values for a variable and
Yes,
how
yes,
often they occur.
yes, obviously. Can you see the whiteboard now?
Yes, sir.
The Bilal query was that, and I think that most of the students may be asking about this, that they've asked what is the distribution actually, because this course is more centered around distribution, so I spending more time I would call as a statistical distribution. What they do, I will not take write down the names of these distribution, but for example, this is data value 1, this is 2, this is 3, this is 4, this is 5, 6, and so on, and this is 1000. So these distribution and this is the domain of the distribution. This will they were so they assign weight to this distribution, or what we call as a likelihood. So assign w1 to this data, this w1, or I should call as a probability p factor, p2 to this data, p3 to this data. Okay, and then similarly to all of this to there's p100 to this data. So all of these data value is 1, it's 2, and obviously in certain cases in start from minus values, it can start. So just for the sake of understanding, I am telling you that these are the data values 1, 2, 3, 4, 5 and 6, and the distribution assigns a weightage factor or likelihood factor or probability to these data values, and obviously these governs these probabilities uh, uh, define that what is the chance of appearing these data values 6 or 5 or 2 or 3 or 100 or 1000 in real data set. So obviously if the p1 is very low, it means the chances of occurring the value 1 in the real data is very less. Example, p6 is very high. For example, the p in this p1, p2, p3, p4, p6 and p100, the p6 is the highest. This p6 is the highest. So it means that the values 6 and the values near 6, they are more likely in the data set. And obviously in this case the mean value will be near the mean value will be near 6. Okay, because the p6 has the highest weight. So and tell me one thing, what about p1 plus p2 plus p3 plus p100 is equals to
1.
1, because all of the probabilities they must be equal to 1. So and obviously you can see that this is the only easiest way in which I can define that what is the distribution. So for example, if the distribution, if there's 1 to 150, so if the distribution gives more weight to data set in the middle, I repeat, if the distribution gives more weightage or more probability to data in the middle, obviously then these values will appear in your data or in your marking. For example, if they are if the marks are, if these can be the marks of the student, 1 can be your marks, 1 2 can be your marks, 100 can be your marks. So if a teacher gives more marks in the middle of this range, so and less marks and then in this range he gives equally less marks, so this will like this. So these are the values, capital X random variable. This is the distribution function. So okay, and then this will be something like this, what you call as a bell curve. This is called as a normal distribution. Normal distribution, also called as Gaussian distribution, also called as bell curve. So because this is the distribution here, Gaussian distribution. And for example, if this distribution which I'm writing here, which is something like this. For example, if distribution something like this, so you can see that it's like this. Okay, so this is random variable values, and this is the distribution function. I will tell you more about distribution, how it is being plotted, but this diagram should give you a clear indication what is a distribution function, so or density function, because this is called as probability density function of variable distribution, and this is probability density function of normal distribution, and this is probability density function of exponential distribution. In exponential distribution, you can see that the area under the curve, you see that in any case the area under the curve defines the probability. This defines the probability from this value a to b. You can see that this is the range, and you can see that the higher, as soon as the values are getting high, the probability of occurrence they are getting low. Okay, so this area here is less than this area here. Okay, so in this case this is light, what we call as a light tail distribution. There is no extreme value in this case. So, and for example, if there's a distribution which generates data like this, like the tail of the distribution, it does not decay too much slowly. It just flattens like this way. I hope you can see this. So obviously in this case, as soon as the data values get higher and higher, this mass does not decay, so the chances of extreme values are high. The chances are high, extreme values are high. So because in this case, if in Karachi, minus 10 is possible, or just like extreme values in your context are possible. So this is called as a heavy tailed distribution. Heavy tailed. Yes.
This distribution form asymptotes.
Yes, because this is a asymptote, because its asymptote is going here, and it does not. The main idea is that asymptote, although it is supposed to touch zero, like obviously, but it will not touch zero. So that asymptote leads to the behavior that the higher values will get the probability of occurrence. I mean that there are chances that the extreme values, because this is the region of non-extreme values, and this is the region of extreme values, which were not possible. Because let me come back to this. In this case, which I have circled here, tell me one thing. In this case, are extreme values possible?
No, sir.
Because the chances of extreme value are here are
very less,
very less,
near to zero.
Near to zero, because as it's almost asymptote is going to zero very soon. But here, in case of heavy tail distribution, I hope you can see this diagram. The tail decay is very slow. The tail decay is very slow. That means that the higher extreme values have still the likelihood or the probability of occurrence is still they can occur in a way. So the chances of occurrence are not negligible. In case of previous case, the chances of occurrence of extreme values were very, very, very low. But in this case, the chances of occurrence of extreme values are very, very, I'm not saying very, very high, but there are chances. I hope that you got some of the idea of the what a distribution does. Okay, so just so it's we will formulate these things in a more clever way, in a more organized manner. But I hope that as you ask this question, so I try to clarify that how does a data distribution behave, and the main thing is that you should understand these things, because if this thing, this phenomena, because this is the main governing diagram, if the distribution assigns the weight factor in such a manner that extreme values get, for example, 100 is a extreme value in this case. Do you agree?
Yes, sir.
Obviously,
Yes, sir.
it is an extreme value in this case. Okay, and is one extreme value in this case?
No, sir.
No,
I
sir.
mean, you should not just say no immediately. You should say that in a context. Please close your mobile. In a context, one can also be extreme value. Okay, so but we can see that if the distribution behaves or assigns high weightage to these values, 100, and less weightage to these values, so obviously the behavior will be something like this one. Okay, so in this case the chances of extreme values will be high. So I hope you got the idea of what is a distribution and what's the different form of distribution and how it works. So coming back to my article, what I propose that Weibull distribution is a best fit for internet traffic. And before I elaborate more on Weibull distribution, tell me one thing, because you mentioned that in this diagram the chances of rare events or chances of extreme events are, or extreme values are high. Okay, because the tail decay is slow, and the high values can get high probability still. Okay, this mass is not decreasing. Okay, so can you tell me one thing, in case of internet traffic, are there chances of extreme values or not?
Yes, sir.
सर ये सर वो
When?
बढ़ती ट्रैफिक जो नहीं, मतलब जो वो एक अचानक से जो आता है,
Yes, in case of, you can call it we have to speak in English because there are foreign students in the class. So I mean, you use the word achanak means always sudden, the sudden traffic, sudden peak, or any, what do you call, what is this thing? I mean, there are so many practical guys here. What is this thing?
DDoS attack.
Sir,
Distributed denial of service.
dynamic denial of service.
Distributed denial of service.
Dynamic denial of service, sir.
No, no, it's not dynamic. It's a
Distributed.
distributed data service. What if your data behaves in normal case, your data you are more, because you all mentioned that internet traffic in case of normal, we can use monitoring applications. So in case of DDoS attack, what happens, that you are monitoring traffic is going smooth, and if there is a DDoS attack, distributed denial of service attack, so there are so many packets of flows coming to your server because the traffic capacity is exhausted or the link is choked. Okay, so in this case, there will be obviously the packet count per unit time. I repeat, the packet count or flow count or session count per unit time will obviously deviate too much from your daily routine, and your resources will be exhausted. Obviously, then this is an extreme event. So obviously, so that's why the deviation from any if you propose a model, for example, Muna says that model ABC is the best fit for the internet traffic. Okay, so it means that that model ABC will generate internet traffic values. It will generate values, will which will it will generate values of internet traffic, the count data and the interval data, which will show that okay, internet traffic values are 22, it can be then 34, it can be then 70, it can be then again 21. So this is the values of the net traffic. But if there is sudden peak, for example, if there is again value like 1010 700, it's such a big amount of data coming per unit time, or again at a big high value. So obviously this will deviate from the proposal of the Muna or any model developed by me. So the deviation from the model is an indicator of anomaly. For example, in my case, I propose, I presented clear proof that Weibull distribution is a great fit for internet traffic. Okay, so the deviation from Weibull distribution is an indicator of anomaly. So I think that what we were writing in here, uh, so that this is, we were filling this column. Coming back to our main slide here, we were doing this thing. So uh, so these are the thing. I so I think that you guys got in more detail answer that in what context I meant security. That the proposed model, if you propose the internet traffic model, so I mean how internet traffic is relevant to security. Because if you propose a traffic model, then the deviation from traffic model is an indicator of anomaly, and that's a very good approach used by many firewalls and things. And if you can see my paper, you can see that my proposed idea of variable distribution has been cited by different papers, articles. And recently one of the articles uh, published in Wiley. I will just share the link here after the break. That they used my work, they cited my work, and they proposed that they did the similar kind of traffic modeling and traffic analysis just like me, which I have done in my paper. You can read my paper again during the break and then see that what they have done. They have done the same work as it of me. My focus was that I worked hard on, you see that the I propose that variable distribution is a best fit. Okay, so you might easily guess that how me or any, because there are other researchers as well which propose different model. But obviously I have not used variable as in the first instance. I might have used hundreds of distribution first, and then I tried to assess their properties, and then I compared them, and then finally I came to a conclusion. There's a lot of hard work behind this. Okay, so this is a quite artistic paper and phenomenal paper, an example for you all to work hard. Okay, so then I have used so many distributions and then analyzed that, uh, and that the new article which was not published by me, but they cited my work. Okay, and then they proposed that deviation from variable distribution is an indicator of internet traffic modeling. So can any of you comment that it was whose fault? Because they just started my work and then proposed the new, and obviously the credit of this thing went to them, not to me. So who was the actual contributor?
Say you, obviously.
But what was my fault?
You didn't give firm conclusions.
Because I proposed that that variable distribution is a great fit. I proposed data fitness. I proposed even queuing fitness. If you see my article, in the very end, I also presented queuing fitness. That when the queuing analysis at the router level, I also presented the queuing analysis at the router level. Okay, and when so I proved from various perspective that variable distribution fits well. But and obviously I did not claim that it's an indicator of anomaly, because it was my fault, although I should have written just few words and it the entire credit could have gone to me. But the other work, they used my work as a base work, although, and they cited my work, and they claimed that deviation from variable distribution is an indicator of anomaly. So that's why, so the entire credit of the new work. And you see that because this is they published their article in the context of security, so that paper got more attention than my paper, although the entire base work was mine. I was the proposer that variable distribution is a best fit of internet traffic in terms of fitness, in terms of data validation, in terms of queuing theory, in case of performance management, in case of congestion control, in case of bandwidth management, in case of capacity planning. All of these things are part of variable distribution. We can do this. But I didn't talk of security. That's why the other clever guys, they just use that. It's just like if there's a night, you can say that, oh, there's no day. No day means it is
Night.
it is night. So that's why. So this happens in research, because if there's variable, traffic is normal. If there's no variable, the traffic is, if the traffic is not matching to variable, the traffic is
It's anonymous.
anonymous, it can be anomalous, it can be attack traffic. So these guys, they use just this contribution, and obviously their work was not too much hard, but they cleverly use. Although I knew, because I was the proposer of the model, I work hard, I always knew this thing. It doesn't mean that I was oblivious to this thing, or I ignored this thing. I always knew that a normal internet traffic will behave like a variable distribution. I knew that an attack traffic, it will differ from variable distribution. Any anomalous traffic or any other, like just like you mentioned, that a certain peak, such kind of anomalous events, when they occur, the traffic pattern will deviate from variable distribution. Okay, because that's the importance of the internet traffic model which I developed, and that's the topic which we are talking about, the importance of internet traffic modeling. Because when there's a model, you can manage traffic, you can understand traffic, you can uncover its randomness, and when the traffic deviates from your model, then you can say that, oh, there's something anomalous going on. Okay, so the other guys, they propose that the deviation from variable distribution is an indicator of anomaly. So that's why in the security context, they prove that, okay, we use TCP anomaly detection method, and the entire framework was attributed to them, and the base work was mine. So again, the main idea that I'm not criticizing the author. They are also researchers, respected researchers. They use my work as a base work, but it should have been easily done by me. Okay, so that's again, the main idea was that to make you understand the uses of internet traffic modeling. And I think that we have gone a long way, and I think there can be much more things here. 9, 10, and before taking a break, what about limitations? Can you tell me the limitation of the internet traffic model? That why this the we have seen so much things about the traffic model here. So now we should talk of limitations. So can you tell me what's the limitation of a model?
Sir, due to uncertain amount of traffic, there are some limitations to it.
I should say that, let me rephrase your word. Not use uncertain amount. You should say that uh, daily or daily variation patterns. There are variations patterns in traffic which cannot be always. There are daily variations patterns in case of internet traffic. You cannot model, and sometimes internet traffic behaves quite unexpected ways. We cannot ignore, although some of the guys mentioned in the beginning. Now I am writing it. Topological factors influence model design. Do you agree with this, that topological factors, or even routing policies routing policies affect model? For example, my work was mostly based on traffic from New Zealand, and there was certain topology, there were certain routing policies. If these topologies and these routing policies change, then obviously the stochastic behavior of the real internet traffic uh, would change. So my proposed methodology or my proposed model might not work in there due to topological factors, due to physical layer aspects, due to the link layer aspects. Similar the case with the routing policies. The differences in the routing policies, or even the load balancing policies, they can affect the choice of model. The same model, when you change topology, if you change the routing policies, the model may behave. The model may not match the real internet traffic. So these are the limitations with internet traffic. And I think you can add more. Yes, please. What are the limitations of an internet traffic model?
Bandwidth limitations.
I think these things come under topological factors, because these define uh, uh, bandwidth limitations. Every topology has a different bandwidth, and or I mean, I can write it. Uh, Let me be more general. I can write as a physical layer parameters like bandwidth, end-to-end delay. They also affect packet loss, delay,
Sir, media
bandwidth,
faulty.
fault. Obviously, these things are topological factors include faulty media. Okay, if the media gets fault too much, then obviously there will be reconvergence of routing tables, and there will be traffic going to a certain link again and again. So obviously, this will add to the unexpected nature of internet traffic. So this is also already covered. So you can see that a mathematical model of internet traffic, it has so many uses, and there's also limitations as well. We cannot always depend on internet traffic. A mathematical model of internet traffic cannot always be useful. Sometimes it can lead to stupidity. It can lead to disaster. Do not That's why don't always trust on the maths. In certain conditions you need to see the ground realities. I think that our net knock operators are sitting here. They will appreciate that never maths helps. In some cases it really helps, but in some of the operational cases you cannot wait for mathematical model. You have to be very realistic. Okay, so I think that limitations of the and I think that one of the important factors here is that uh, you see that hidden correlations, they add correlation in traffic, makes modeling very difficult. Traffic, they make modeling very difficult. Why? Can anybody tell me before break? This is something more analytical question. Why hidden correlation? And I hope you know the meaning of correlation, because that's more about dependency in the values of internet traffic or any distribution. So if there are hidden correlations in the data, that obviously makes your modeling very difficult exercise, because the reason is that most of the statistical model, like variable distribution, exponential distribution, or other distribution, they generate data based on identical and independent distribution. So data is IID. So that's the answer. So once again, I would advise, because although it's not my mandate to teach you here what is a distribution and density function, you all need to have some background of these things, because otherwise the core aspect of this course will be affected. So although I will try my best that I will teach you these things, but I will not be able to teach you the basic stats in this course. You have to read about what is a random variable, what is the density function, what is a distribution function, and then obviously we can talk more on this, and then understand more of the dynamics of the internet traffic. So I think we should take a break now, because I'm speaking continuously since 6 p.m. It's now almost 7:30. So so we will talk more about these things, and after the break we will start again. I think we should start at 8 p.m., and then we will take 40 minutes class again. And so let's have a half an hour break. Okay, so we will start again at 8 p.m. I will start slightly before, like 7:55 or 8 p.m., so that 8 p.m. we start exact. Okay, so I hope that you got there was some comments I could not see. So I hope that you all getting what I'm teaching here. So I will be more starting numericals from the next class, but I have some minor exercises for you after the class. So we will start uh, on 8 p.m. Okay, so is it okay for you? And you will join using the same link. You just click on the class link, and then you can join the class. Okay, so any question? So okay, we come back at 8 p.m. and we should leave the class now, and there's a break, and then we start again at 8 p.m. Okay, thank you very much, and just click the same link, okay, on the
Okay,
class
sir.
header. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thanks.
Thank you, sir.
Thank you, sir.
Hi, Assalamu alaikum and welcome back. I hope the previous session was okay and you all got some of the things I understood. In this session, I'm going to talk about few more things, and let me open my whiteboard. This is my screen. Um, okay, I hope this screen is clear. Uh, just a moment, I'm getting some messages of some of the students not. Some of your friends are messaging Mansoor. Sorry. So I will. Okay, sorry about this. Some of the students are not able to join because they are not using the method for joining. So I've asked them not to call me here again. So this was the. I hope my voice is clear. Are you able to listen to me?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
In the previous class, we mentioned about the uses and limitations of internet traffic model. In any case, and one of the important factors which we did not discuss in the previous class, in the previous session, was that I think you all agree that data storage is a great problem these days. Big data and other things, there are so many factors. And if you see that, what is a big data? Can anybody define big data? What is, because this is a quite hype these days. Big data. This is quite common thing, quite a hype these days. So who will define big data for me? Anybody? Don't be shy. You can just search on the internet and just tell me. Just read whatever you Google out.
Sir, large volume of statistical data.
And I think that while searching that, you might have seen four V's of big data. You can just search on Google by typing what is the four V's of big data. Uh, mm, like volume, velocity. I hope you can see what I'm writing.
Variety.
Value.
Yes, sir.
Volume, velocity,
Value.
Variety.
variety or variance. Something call it as other thing. What was the fourth V? Can you tell me?
Value.
Veracity.
Veracity.
Variety,
Veracity.
veracity. I think if you see, in actuality, there are actually 27 V's. There are 27 V's these days. In a paper, I was saying that there were 27 V's of big data these days. Veracity is more about variance in the data. Variety is more about typological factors in data. Velocity is about speed in the data. In our case, it can be bps or mbps. Volume is about size of data. So so these are the challenges, and I hope you all will agree that most of the V's uh, can be very easily justified in case of internet traffic, the raw internet traffic, because all of the e-commerce and all of the things, they all depend upon not just content retrieval network these days. Now it's a content generation network. Fundamentally, I think all of the operators here, they might agree in that the fundamental design of internet was supposed to be a content retrieval network. It was just supposed to fetch web page. It was just supposed to be a client server model initially in 1990s and early, but the same architecture is now being used for a different purpose. Every node is a content generator. My cell phone is a content generator. Your laptop is a content generator. So there's so much. So internet traffic modeling, I think that what we have discussed, this whole this whole because the internet traffic, based on the dynamics of user applications, the evolving nature of user application, WhatsApp, Facebook, and the traffic trend is changing. And I think that, do you agree that, because traditionally the download traffic at a certain endpoint node on my laptop or on your laptop on my cell phone, the download traffic is always less than the upload traffic. Do you agree that in a certain link, especially at the endpoint level, download traffic is always more than upload traffic?
Yes.
No, sir.
Uh,
Yes,
why?
sir. More.
That
Yes.
depends on
It depends on.
the depends on cable modem or DSL. That depends on
No,
in
no,
which
Mona.
technology.
Here I would like to differ with you. Sorry, Mona, because the thing is that that does not have to depend upon cable modem or high speed DSL modem or something other kind of, if you have even fiber optic coming at your home. My question
Mm.
is more relevant to the upload traffic, because from the next class I will be talking of more of the statistical aspects of internet traffic, and you will need to understand what I am teaching here. So the thing is that, what I am talking, my question is very simple to all of you, because there are almost 34 students sitting here now. Is download traffic is more than upload traffic? Traditionally is always, I mean, is always more than upload traffic. But now these days, as I have already mentioned, that internet is not a content retrieval network, because in previous designs, your my laptop or my cell phone is just we are just supposed to look at the web pages, and we are not supposed to generate web pages. But I think that there are so many, we should not ignore while modeling internet traffic. We should not ignore these v's, the big data v's. Okay, although I believe that the big data, I as a researcher believe that the big data is a great hype. Okay, there's nothing truth in something like as big data. There's no such thing as big data. Every data has its properties and statistical modeling. Main thing is statistics. Okay, so same goes with the AI. There's always statistical patterns, not any intelligence. So this is my philosophical remarks. They might be controversial for you, but the thing is that there is nothing like a big data in this world. Everything is data, and data has its importance. Data can be small data, data can be big data, but we need to understand the statistical properties. So the stats is the main key. The stochastic processes behind the big data, which we do not study in this case because they are difficult to understand. So just looking at the data aspects is easy. That's why it's very, we are getting so much boom of big data courses and everybody talking of the big data, but nobody talk about the stochastic processes, the underlying statistical patterns of the big data, how they are generated. So the big data is something about the volume, velocity, variety. So we should appreciate these things, but we should not ignore the underlying stochastic dynamics. We should not ignore the underlying modeling distributions. So this is the traffic models which we need to understand clearly. So the thing is that what I'm trying to say, that we should not ignore the big these factors, and also we should not ignore the application behavior. There are peer-to-peer applications. Okay, there are applications like Facebook, in which upload upload traffic is might be more than download. I hope you can see what I'm writing here. So I think that in this behavior, like having peer-to-peer applications, like social network applications, because social network applications have traditionally have now great impact on internet traffic. So what I would say, one thing, that internet traffic modeling exercise will continue to remain a modeling challenge always. I propose that variable distribution fits well to the traffic current these days. But my proposition, my argument, or my article may not be valid after 10 years, because due to the changing nature of internet traffic, the dynamics of the internet traffic, upload traffic is getting more and more, and download traffic is getting less. That I think you will agree, because everybody of us is using Facebook, social media, Twitter networks. We are using this, and we generate content always. I am uploading several videos. I upload several of my videos every week. I upload my pictures on Facebook. I upload various content on Facebook, and that's why. So the trend of the upload traffic is getting more and more. And this do you think that this behavior of traffic asymmetry also applies to the backbone core network, or it is only applicable to the access network? Because my I was talking more about access network at the moment, because in case of access network, uh, always traditionally download traffic has been more and upload traffic has been less. But due to this endpoint application, due to this peer-to-peer application, due to the social network application, the upload traffic is increasing, and at some extent, upload traffic can be more than download traffic. So this remark holds for access network. Do you think that this remark also holds for backbone core networks, the traffic in the backbone core networks? Or in case of backbone core network, traffic is always symmetric. I mean, upload and download both almost around the same time. Yes, please. So what's your remark? Is the traffic asymmetry only applicable to the access network, or it's only applicable to the backbone core networks? So this is internet backbone. This is tier 1 network. This is tier 2 network. These are ISP1. This is ISP2. Similarly here again, tier 2 network. This is ISP1. This is ISP, or it can be ISP3, it can be ISP4. The tiers are the same. So just an example. So my and these are the comments that uh, the traffic behavior here, like link 1 and link 2. Link 1 is also a back, and here also there are different kind of cable net operation. For example, this is cable net company here. This can be LTE company here. There can be a company using Ethernet here. So so it should be called as L1, level 1, level 2, and this is level 3, L3. So the traffic asymmetry at L1 is more, traffic symmetry at L2 can be less, and traffic asymmetry and L3 can be less. What I'm saying that, so this goes like this, because this is the traffic path here. So the traffic is more asymmetric at this side, traffic gets more asymmetric at this side, and traffic gets more and more symmetric in this and in this, and also inside this. So can anybody explain that why internet traffic is getting symmetric? I mean, yes, when I say symmetric, I mean that traffic in upload and download directions are getting equal. So why traffic is symmetric in backbone core networks, and why traffic is asymmetric in case of access network? Who will tell me the answer?
Sir, because bandwidth is being utilized to its maximum on tier 1 level 3, and on level 2 people are using like ISP, so it's asymmetric over there, I think.
I think, can you tell me that in which tier, because I have shown tier
The tier
1,
one,
tier 2,
tier one. So tier one, the
highlight.
maximum bandwidth is being utilized.
Mhm.
That's the reason.
What I you see that I have written a word called as multiplexing level, or in case of research we call it as a superposition.
Okay.
So I think all of you agree that internet traffic suffers from superposition and also decomposition. The the upload traffic the upload traffic, when traffic goes from my laptop to cable net operator, another other thing, there are so many users in my area which are using the internet at the same time, so my traffic superposes with their traffic. Okay, and then there are routing policies and kind of thing. Okay, and the traffic then reaches the ultimate endpoints, and the return traffic coming back to my laptop, your voice is my return traffic. So then traffic suffers from the phenomena called as decomposition, because the traffic comes back till my ISP tier 2, then lower grade ISPs, and then back to the my cable cable net, and then and the local switch or cable modem breaks, splits, and then it goes into my street, and then so there's both superposition involved and decomposition involved. In this subject you will study in detail many of the superposition algorithms, many of the decomposition algorithms. Okay, and but the thing is that what my question was that the I was saying that you should understand the multiplexing level. You should say that as soon as multiplexing level increases, the traffic asymmetry decreases. I repeat my word, as the multiplexing level increases, the level of the traffic asymmetry decreases. Okay, so the this causes, if this level increases, and when I say level of multiplex, can you tell me one thing? Is the multiplexing level at tier 1 is high, or the multiplexing level at ISP 2 is high? Which one is high?
Sir, ISP2 is high.
And when I say multiplexing, it means multiplexing of the flows. At tier 1 it is high multiplexing level, or at tier 2 it is high multiplexing level?
So I think tier one, because more
Tier
networks have been collided into the same network.
Yes, because tier 1 is supporting tier 2 different backbones, so there are too much multiplexing at tier 1, and then there's less multiplexing in tier 2, and then the multiplexing level decreases as I move towards your home network. Okay, that's very obvious. So the reason of the asymmetry, I hope that everybody will understand that these remarks are very obvious. In access network like this, sorry, like this in L1, that because the level of multiplexing is less there. In case of L2, the level of multiplexing is getting high, so traffic is becoming smoother in both directions. In case of L3, traffic going from tier 2 to tier 1. L3 link, which I this link, this area, again there's so much multiplexing because the traffic from ISP1 also coming, the traffic from all of this network is also coming. So so this makes traffic smooth, and and technically speaking, mathematically speaking, the variance in the traffic gets reduced, and the chances of extreme values in the traffic also gets reduced, because due to the high level of multiplexing. So the multiplexing always, which we call as, gives certain guarantees. And the thing is that if we are able to model this multiplexing phenomena, this will really help in your internet traffic modeling, because it introduces certainty in your traffic. It makes your traffic smooth. Okay, so but the modeling exercise in this part, in the lower tiers of internet hierarchy, like in access tier, it's difficult. And that's why I want to illustrate that internet traffic modeling is a bit difficult exercise in case of access network, because of low multiplexing levels, because of more randomness. And I think that do you agree that the internet traffic is more random in access network and less random in backbone core network? Do you agree, and
Yes,
why?
sir.
I
So
think it's
because
obvious, because
Symmetry.
internet traffic is less random in this part. And internet traffic is
Sir,
sorry,
could you just
internet.
repeat the question?
My question is that internet traffic is more random in access side. This is access network, and this is core network. My question is that where internet traffic is more random, access side network or backbone core side network? Where is internet traffic is more random?
Access that.
Sir, at access
Why?
side.
Why? Any reason? You should have some reason for this. Okay, what makes the traffic in access network more random, and what causes randomness to decrease? Because when I say packet traffic, you must understand that what I mean. I mean packet count data, and it's a time series data: 12, 13, 70, 74, 100, 2, 5, 10. This is kind of time series data. Packets, number of packets per unit time, number of packets per second, number of packets per millisecond, number of packets per microsecond. So these are the time series data. So when I say traffic, so you should understand what I mean. Per unit time. In certain contexts, we can also mention flow counts per unit time, and then later on we can also mention session counts per unit time, because when we talk of the structural components of internet traffic, there are three components which we discussed in the last class: packet, flow, and session. And I think that you have understood the challenges in identification of the packet, flows, and session in the previous class. Okay, so why packet count data is more random in access network, and why this count data time series is less random in tier 1 networks.
Well, sir, from the ISP point of view, there is a tendency of more random data from the access layer. This is from the ISP point of view. And from the organizational point of view, we are pretty much sure that what are the traffic types and patterns at the access layer. So,
Any other remark? Any other remark that why internet traffic is more random in access network and why it is less random in backbone core network? Abdullah, are you from Yemen? You also there? Abdullah, can you listen to me? Abdullah from Yemen.
when it comes to the core layer, if the core is initiating or originating the traffic, we know that we have the certain applications, so there is a less randomness, I would say.
Mm-hmm.
Um, and from the ISP point of view, that I've already told you, that access layer it is more random.
I think you have mentioned some of the very important things which I wanted to mention. Thanks for telling about the application. I will ask one more thing about applications, but I think that the major answer to my question is that uh, uh, the side which is more close to humans. Okay, because human factors always play an important role in internet traffic modeling. I think you all must agree is that there is a very good journal. The name of that journal is Human Factors, and that Human Factors journal publishes a lot of articles about internet traffic modeling. So human factors always play an important role in internet traffic generation, and then obviously indirectly they will play an important role in the internet traffic modeling. So I repeat, the human factors all the access pattern by user. I click a website. When I click a website, what is my think time data? What is my page view time data? Research articles which have worked on the modeling of the user think time, and how long a user and a web browser loading time, and page load time is also another thing. But that user aspect, that how long, because this thing ultimately controls internet traffic generation. Because when I when I hit a URL, google.com, so what happens behind? There's a connection handshake packet, and then the response comes in. Okay, then how long I view the packet, how long what is the because during my reading time there will be no packet generating. If I keep clicking web pages, then there will be traffic generating. So this kind of access, the random access pattern by users, that generates too much randomness in the access network traffic. And I hope that you agree with this. Get this. And obviously modeling this random traffic is more challenge. And you know that why traffic is not more random in backbone core network. And I think that the answer is written on your white on the board. Because just tell me one thing, the random traffic from this side rest. So tell me one thing, uh, this is a very important point. I think let me be more clear. This is smooth traffic. Smooth traffic. So what will be the output? Smooth or not?
Smooth.
Smooth traffic. Okay. And then this is random traffic, and this is random traffic. So if we multiplex random traffic stream 1 and random traffic stream 2 coming from two different internet service provider, so what, and merging at the same router, this is your router. So what do you think, the output will be smooth or random?
Random.
Why?
So because both are random, sometimes the data is coming, sometimes it's not. So there's up and down in the stream.
I think the you can answer if you can yourself generate a random variable time series data and mix them, add them together. Okay, so if you add random values together, will they become smooth, or they will become more and more random? You should think on this, that if there are random variables and which have too much randomness, and we add them together. So you I for let me illustrate more. For example, if I add uh, another link here, I multiplex another link here, keep increasing number of links. So will the output at this side, will it be random or it will be smooth? Let me rephrase my question. If we increase the level of multiplexing of random traffic, what will be the output? It will be random, it will be smooth.
I
Because
think
this is
smooth.
something, this should be, I mean, I should not say it's smooth. I would say that it will be less random. It will be less random. It should be less random. So that's actually a normal next actually a normal behavior. What I want to try to illustrate that if you the multi due to multi, and this is called as a this phenomena of random traffic mixing with random traffic and mixing with random traffic. Three links are multiplexing and their randomness is decreasing, is tending to a smooth. That is called as in our science, that is called as multiplexing gain. Because the high the level of multiplexing,
So
the
are we
traffic
talking about
become.
the sir? Sir, I have a question.
Yes,
Are we talking
yes,
about
yes.
the rate at which the traffic is being generated, or the type of traffic that is being like?
I'm
Is
talking
it
in a very simple manner. I'm talking of because obviously your question is valid. The rate here can be different. The rate can
yes,
be
sir.
different. The rate here can be different. I agree with that. That R1 here, the R2 rate here, the R3 rate can be different. The multiplexing links can have different rates. But I'm just talking of packet apple and oranges. We should talk in terms of language which everybody understands. Okay, so in terms of, because I agree with you that the rates can be different. So that's why I just I'm talking of the packets per unit time here, times, for example, 2 4 7, and again 7 4 2, here 18 9 0 1. So these are the packet count values per unit time, packet count values per second, packet count values per millisecond, packet count values 10 per 10 millisecond. So these are count variables, whatever the rate may be. whatever the rate may be. These are the packet count values. So we are multiplexing the packet count values, taking from every link, and in a single time window we are multiplexing. So obviously you can see that this multiplexing will cause, because here it will be random. The more random part may collide with another random part, and then if we add them together, the traffic will become more and more smooth. So that's why this is called as multiplexing gain. So this is the normal behavior. So multiplexing of links which have random traffic, and obviously which link has random traffic. The traffic coming from access network has random traffic, because of what? Because of, I've already mentioned, because of user behavior, user access pattern. Due to user access pattern, the traffic at the access network is random. And when this traffic comes to the backbone core network, just like I'm showing here in this diagram. In this diagram, what I'm trying to model is that the traffic coming from back access network is multiplexing at a core router. Okay, this is a core or backbone router, and the traffic is becoming less and less random. So this is something called as normal multiplexing gain. So this, having said this, having said this, let me again say something. Uh, this is another link. This is another link, and this is another link. This is a router here, or this is outgoing link. And again, I'm talking of on the my left side. This is access networks, and this is backbone or tier 1 networks. Okay, the traffic here is random. And by the way, I did not consider the case smooth traffic multiplex with random traffic. What will be the output?
So smooth.
It will be
Smooth, I think.
Please
no. I
random.
mean, it will be random, because smooth is smooth. It will be random on top of the average value. Okay, so smooth traffic has some average value. If you mix with the random traffic, okay, so then obviously on top of the average value of the smooth traffic, there will be more randomness. Okay, so that it will be random. Smooth traffic multiplex with random traffic, it will add randomness in smooth traffic. So coming here back to the thing, because in the previous case, so this was my case one. This was case one. Smooth traffic multiplex with smooth traffic, the traffic is smooth. And then random traffic multiplexing, the traffic becomes smooth or less random. But this case has a dichotomy, because various in research articles, various authors investigated the traffic from different access network, and then they found out that in case of when random traffic 1, random 2, random 3, okay, when it mixes with, then the traffic becomes more random. So this was the thing which some of you were saying, that in some special cases, and there are research papers and there are evidences in multi advantage due to multiplexing. And how it is possible? How it is possible? I
Can you
just
repeat
want
the
to have an
question?
answer from you. I'm repeating the question again, that if we multiplex random traffic, random traffic from link 2, random traffic from link 3 on a router, then in the previous case, we observed and we logically justified that a traffic will become average out, and it will become smooth, and it will be less random. So this is called as multiplexing gain. And but this case is not always observed, the same case, because you can see that the input side in this case and in this case is the same, because all the traffic is random input traffic. But we have observed, I am telling you the observation is that if we keep increasing level of multiplexing of the random traffic, the output becomes more and more random. So what can be the prospective reason? try in any simulation tool, MATLAB or R, I have told you, if you generate random variables and then you find out the average. And I think that you all know that addition and average because you what you do, you tell me one thing, what is doing, what mathematical operation is there? It is plus, obviously it is plus. The traffic values and this in this time series, they're all I'm adding together. The packet here, we add, we just add. So I think that plus operator, or if we see the average behavior here, so average of value, does it uh, uniforms the data, or or it, or what I should I mean, average operator, it uniforms data, it destroys randomness. I think you should all agree with this, that averaging or plus, if you add random data together, so it must destroy randomness. Averaging always just destroys randomness. Okay, I think you should all agree with this, that average operation or plus operator, it destroys randomness of random variables. If you add them together, if you add random variable together, you can just verify in your MATLAB that you generate exponential random variable 3 times, you add them together, and then you just okay. So this is less random. So what should be the reason, that what should be the case, that if you add random traffic and the resulting output traffic is more random? Because research papers, it has been reported by Cisco, it has been reported by Huawei technical reports, that multiplexing cannot always be random, the resulting traffic cannot always be less random, it can be more random, it can be more random. Even the highest for example, if the random one is the highest random link, random two is also random, but random one link is highest random link, the most of the random traffic is here. So what should be the case, that in which what should be the reason that if you're multiplexing, increasing level of multiplexing, you are not getting multiplexing gain. I mean, the resulting output link traffic is more random than the incoming traffic. What should be the reason? Just think on this. I'm not asking you the complete mathematical theory behind this. Just tell me the reason. Because it is obvious that average operator or plus operator, when you add random variable together, the randomness destroys, it becomes more and more uniform, just as the case in this case. In this case, which I am showing here, which I am circling here, it's normal case. You are adding randomness, and due to averaging and due to plus operator addition, the randomness is getting destroyed. That's a normal phenomenon, that's a usual case. But in this case, what I'm saying, I'm saying that it has been reported several times that adding random variables together, or adding traffic from random traffic from the links, uh, then the output link traffic is more random than any individual link. So what could be the reason? Just try. Yes, any link, any idea? Come on, there are so many students sitting there. Why you are silent?
Because of the average theory, because whenever you apply average, the value
Mhm.
will be greater than the least of the input.
Mm, uh, you say that whenever you apply average, the value will be the greater than, that's true. But what if the input has extreme values? I think I mentioned if you attended my first session, I was talking of extreme values. Okay, the distribution which has extreme values, the distribution which gives high weightage to the data with large values. So I think I have already given an answer in a hidden form. I have given you an answer in an hidden envelope.
Yes, sir. If the signal is, if the input is very erratic, or it presents very extreme random numbers, then overall the
Yes, in this case,
average will
yes.
deviate.
Yes, so in this case, if the input is coming from distribution or internet traffic at link 1, link 2, link 3, which is multiplexing together, if this traffic has extreme values, okay, if this traffic has extreme values, or more technically speaking, or more mathematically speaking, if the distribution of link 1, distribution of traffic distribution link 2, and traffic distribution at link 3, if they follow extreme value distribution or heavy tail distribution, which I just shown you in the lecture in the first session, then the multiplexing of such traffic will not give you any advantage. It will not smooth out traffic. The traffic can be more and more random, and I can prove it mathematically, and I can prove it by diagrammatically, I can prove it by simulation. So I think that I tried my best to give logical arguments till this class, but I think that I hope you got my points, the importance of the data distribution in case of internet traffic. So we will discuss these controversial points more in a mathematical manner, and you will enjoy while this discussion goes on. The idea of telling you is to make you appreciate the idea and the beauty of underlying statistics, that how come when random traffic multiplexes, how can it becomes smooth, and how come when random traffic multiplexes, the output is more random. So such kind of discussion is very important and central to our course. So I have still not written down the course outline, although I have shared you the book, and the book is very clear. I will teach topics from chapter 1, 2, and 3 mostly, and I will follow another book. But the reason for this class was just to appreciate you, just to make you understand the importance of the internet traffic modeling and the underlying issues. Okay, so I hope that you got an idea of what, because that should be the takeaway of today's class, that you should understand the importance of the internet traffic modeling, its importance, and the underlying challenges, the challenges of multiplexing, the challenges of the decomposition. At the moment till now, it's 8:42 p.m. at my laptop. I have not discussed any issue with this theory, because there's the other phase we have not discussed, and the other phase is what you we call this, you will call it as a traffic splitting, or traffic decomposition. We have not. So just as a query, if the traffic is random, this is a router here, this is incoming traffic, and this is outgoing traffic. So if the traffic is random here, so what should be the traffic properties at link 1, link 2, and link 3? So if the incoming traffic is very random, and then what you expect at this side? The operations guy, we have knock operators there. Can any knock operator from bank alpha or anything can at a backbone link is random, and it's being splitted into three links: link 1, link 2, link 3. So what should be the traffic profile of link 1, link 2, and link 3? Should it be all random, or should be one random, one smooth, other random, or a mixture? And what should be your thinking logic on this?
So logically, I think if the random data is like if we take three sources of the data that is being random, then if it all belongs to L1 outgoing, then it will all go through L1, L2, and L3 will be on the hold. And if it's like very, very, very random, then all three of them can be smooth at the same time.
Okay, that's one view. I would not give an answer at this moment. I'm just eager to have your point of view. What you say? If the incoming traffic is random and it is being splitted or decomposed, what do you say about the randomness behavior of the output links? Any other remark?
Sir, all three splitting will be random, as the incoming traffic is random, as you don't know the which rate limit is coming, and there is unpredictability.
So you mean that if the traffic is smooth, incoming, it is also possibility that the traffic is smooth here. So you are saying that it cannot be random here at the outgoing link.
So it can be random. That's what I'm saying over here.
So
If
there a random traffic can
like
be split into random traffic It can be. You should. I think that being an engineer, you should make a table. You should make a table that
Can I say something,
that
sir?
that randomness table, that you should make an input kind of table kind of thing, and then study the different possibilities. Okay, you should study the different possibilities here. Then you will be better understand the cases. A random input and can be after splitting it can be more random, and a smooth input can be result in a smooth outputs. And it's also a possibility that traffic is smooth here, but it is very extreme value here, and on this link it can be very extreme, it can be very much random at this link. So there are different possibilities. So the thing is that we do not have to look at this from the point of view of operations. uh, you are right that somebody pointed here that the type of the network or topology here, the topology here that can play a part in the traffic control, or the number of user at their site, number of user and their behavior, their access pattern. Because you know that the download traffic has is correlates with the upload traffic. It happens because the get request result in the wget result in w post. Okay, so this is the upload traffic is there's a correlation between upload traffic and download traffic. It's true. So it depends on the application. Of course, we are not going to see the application factor. We have to develop mathematical models which can model this process of decomposition, and it must include every possible factor. If there is a random input and the random splitting, the model should be able to model this kind of thing. If there is smooth traffic, under what conditions the smooth traffic must be decomposed into smooth traffic, under what conditions or under what parameters smooth traffic can be decomposed into random traffic. Okay, so this, and then which link contains more randomness. And obviously it's not always possible that if the traffic is random, then you just bypass all randomness to only one link. I'm not saying that all of the links output link will have equal randomness or equal smoothness. There's not only possibility. So the thing is that uh, I'm just trying to introduce you with the challenges. In case of statistical language, we use uh, we do not use the process, the word called as splitting or decomposition. We use called as random thinning. The random thinning is the actual statistical word for this process of splitting. So again, this is you see that this kind of multiplication
Sir, if I may ask a
or
question for clarification.
yes, yes.
Sir, if, kindly if you can tell me or differentiate between the random traffic and the smooth traffic. Can you
Mhm.
differentiate please and tell me?
Yes, I think if you
Give a some sort of example.
mentioned about the distribution. So a smooth traffic is more likely which follows uniform distribution. Coming from a distribution has probability not much deviation. But in case of random traffic, the traffic count data follows a distribution in which the probability counts of the traffic, the likelihood of these counts is so much random. And in case of random traffic, the other, we also studied about the category of extreme behavior. And I hope that you were there in when I was talking about this kind of thing. So this is and then you also must appreciate which distribution in statistics and applied probability are used to model smooth traffic. Uniform distribution is usually modeled used to model smooth traffic or even exponential distribution. And Weibull, Pareto, log normal, these kind of distributions are used to model random traffic. I hope I was able to answer your question.
Okay, sir. Thank you.
But still, we will discuss these things in more detail later on, because
Sir,
you will
I have a question.
study. I will teach you about the random variables, and obviously random in case of distribution, there are distributions which have low variance distribution, because there are some distributions with high variance, and even there are some distributions with infinite variance. So the thing is that if you want more clarity, that handling the distribution with the infinite variance is more challenging and more interesting, and that's more relevant to your networking courses than your networking traffic in backbone core network and access network. And I remember that in the previous lecture, in the previous course when I taught to the your previous batch, when I it was used to be physical class. I spent almost 5 to 6 lectures in teaching which were quite much relevant to this topic which we were studying. Unfortunately, we are not at in the class at the moment. Otherwise, I would have shown by using the board. Although I'm still using the board here. So, but the thing is that at the moment, I just wanted to that what's the behavior of the random traffic when it suffers multiplexing, and what's the behavior of the random traffic when it suffers demultiplexing. I just wanted at the moment, I also do not want you to understand the actual definition of the randomness or smoothness. We will come to this. I will tell you the matrix of randomness, I will tell you the matrix of smoothness, and they will all be very useful for even for practitioner guys here. Take it. Okay. So but the moment the thing which I wanted to tell you, that superposition, I think you must appreciate one thing, right? What are the shoes on this side and what are the shoes on this side? And I think that you must appreciate one thing, that the study of such parameters, such phenomena is not quite easy as you see. This splitting modeling, the splitting behavior is not so much easy. You have to model every aspect. Just make the table and then see that you have to quantify, you have to justify every row of the table in one: random input, random output, smooth input, random output, and then the link and on the link side you can also make more and more columns. Okay, so the thing is that the modeling of the traffic multiplexing or superposition and the traffic decomposition or the traffic splitting is another area, and both are quite challenging to study, and obviously both are very much useful in case of traffic forecasting. You see that if you model this, if you model this kind of thing, you will have a lot to say about the network capacity planning, the network security, and the other issues. So I hope that you all appreciate the things which I'm going to teach. I want to introduce you to the dynamics of this course, and I hope that you will understand what I will be teaching in the next course. Okay, next in the next lectures. So any further question?
Sir, I have one question. Sir, will
Yes.
we be doing practical
I
examples
think
of this?
no. I think in case of in MS we have a different model. We have a we all teach theory here, and some of the teachers like me, we do simulation based labs. I will just show you the R tool, R Studio, and I can just show you class. We have no practical in MS, but we have a thesis part in there are 6 credit hour thesis part in which you can choose a full practical course. It will be completely a project.
Okay,
It's
sir.
called an ISP. Okay, so I hope as my talk here is clear and you got the idea of what I will be teaching. And the main idea was that during this lecture, that the main idea was that I have to stop this. The main idea was just to illustrate the importance of internet traffic modeling and what are the underlying issues. I hope you all got this. So I have to finish the class now. Thank you for your participation. I have taken attendance by the automatic attendance tool, the G Suite Meet tool. So I think if there's no further question, I'm here for any question. But if you have no question, you can leave the class now.
Thank you, sir.
Thanks.
Thank
Thank
you.
you, sir.
Thank you, sir.
Thanks.
Thank you,
Thank you,
sir.
Thank you,
sir.
sir.
Take
Allah
care.
Hafiz.
Thank you,
Thank
sir.
you,
Thank
Allah.
you, sir. Allah
Allah
Hafiz.
Thank you.
Hafiz, sir.
Allah Hafiz.
Take care.
Thanks.
Is that
Allah
a
Hafiz.
lot?
Allah Hafiz.
सर एक क्वेश्चन है नाउ क्लास ओवर हो चुकी है तो आई थिंक आई कैन टॉक टू मी सर
आपका नाम क्या है?
जुनेद जुनेद सर
जी जुनेद बोले।
सर ये बताएं कि ये जो स्टोकेस्टिक प्रोसेसेस जो हैं ये
जी
जो रियल वर्ल्ड सिनेरियो के अंदर
जी जी
कॉर्पोरेट ऑर्गेनाइजेशंस के अंदर जो है वो ज्यादा एप्लीकेबल नहीं होते इज इट ट्रू और ये नॉर्मली ज्यादा एप्लीकेबल वहां होते हैं जहां ज्यादा डेटा का इनफ्लो और आउटफ्लो होता है लाइक टियर 1 आईएसपी और जो सर्विस प्रोवाइडर्स हो गए टीयर 1 टीयर 2 और जो हमारे जो बैकबोन चल रही है पाकिस्तान की वहाँ पर,
जी जी।
वहाँ पर ये एप्लीकेबल ज्यादा है जो स्टोकेस्टिक प्रोसेसेस rather than in at organizational level or infrastructure level. मैं ये पूछना चाह रहा हूँ।
देखिए, आपके क्वेश्चन को मैं दो तरीके से आंसर करूंगा। आप ये बताएं कि आपने अभी लफ्ज यूज किया, कॉर्पोरेट का लफ्ज यूज किया। पाकिस्तान स्टॉक एक्सचेंज में रोजाना स्टॉक स्टॉक की प्राइसेस डेबिट कर रही होती है, मुल्क की इकोनॉमी डिपेंड कर रही होती है, कभी स्टॉक मार्केट गिर जाती है, कभी बढ़ जाती है। ठीक है, देख सुनते हैं ना, आप अखबार में आ रहा है कि स्टॉक मार्केट गिर गई, बढ़ गई, इतने रेट्स हो गए। ठीक है ना। आप ये बताएं कि क्या स्टॉक के जो रेट ऑफ रिटर्न्स हैं और स्टॉक मार्केट का जो ट्रेंड है, टाइम सीरीज डाटा, क्या ये स्टोकेस्टिक है कि नहीं है?
बिल्कुल है सर, वो तो बहुत रियल टाइम डेटा है सर।
और कोई मॉडल बन जाए तो क्या उनके लिए इतनी बड़ी नेमत नहीं होगी स्टॉक मार्केट की, जो स्टॉक मार्केट के लिए प्रिडिक्टिव ट्रेंड्स बना दे, जो स्टॉक्स को प्रिडिक्ट करवा दे, स्टॉक की मॉडलिंग कर दे, तो जो कंपनीज हैं कितना फायदा। और इस पर इतना R&D हो रहा है कि स्टॉक की जो वैल्यू और स्टॉक की सिग्निफिकेंस और उसकी एसोसिएटेड वेट की वैल्यू, कितना किस कंपनी के शेयर का कल क्या चांस होगा आने का, और कल किसका अपना रेट कितना होगा। तो आप तो स्टॉक मार्केट, और सबसे अहम चीज, स्टॉक मार्केट का क्रैश होना या बहुत ज्यादा बूम कर जाना, जिसे कहते हैं एक्सट्रीम वैल्यू। आपको याद होगा कि आज क्लास में मैंने कई मरतबा मैंने जस्टिफाई किया है एक जुमला, जो कि आप लोग शायद उसको इतना अप्रिशिएट नहीं कर पा रहे होंगे। मैंने काफी बार लफ्ज यूज किया, एक्सट्रीम वैल्यू का इम्पैक्ट। ठीक है, तो ये कितना इंपॉर्टेंट है। तो सेम लॉजिक, और सेम लॉजिक गोज फॉर इंटरनेट ट्रैफिक इन एक्सेस नेटवर्क। एक्सेस नेटवर्क इस में इसकी मॉडलिंग की इंपॉर्टेंस ज्यादा है। आपका सवाल ये था कि स्टोकेस्टिक प्रोसेसेस की इंपॉर्टेंस एक्सेस में ज्यादा है, ये कोर में ज्यादा है। आप मुझे एक सवाल का जवाब
नो
दें।
सर, सर ऑर्गेनाइजेशन में जो हमारा इंफ्रास्ट्रक्चर नेटवर्क होता है,
जी
एक्सेस
जी जी।
डिस्ट्रीब्यूशन और कोर जो हमारे लिंक्स होते हैं, वहां पर
जी जी।
इसकी एप्लीकेबिलिटी होती है। डू यू थिंक दैट?
नहीं, देखिए, आपके आपके इसीलिए मैं आपके आपको मैं कह रहा हूँ, आप ये बताएं कि ओवर प्रोविजन आपके एक्सेस नेटवर्क हैं या ओवर प्रोविजन आपके बैकबोन नेटवर्क हैं इन टर्म्स ऑफ यूटिलाइजेशन।
ओवर प्रोविजन डेफिनेटली एक्सेस होगी।
एक्सेस नेटवर्क, नहीं, आई थिंक
ओवर प्रोविजन जो है कोर होंगे डेफिनेटली। तो
ओवर
डिपेंड करता है
प्रोविजन
कि आपके
ओवर
आउटबाउंड।
प्रोविजन नेटवर्क जो है ना, वो कोर होते हैं। आप देखें, ट्रांसफर आपका कोई दोस्त अगर ट्रांसफर में है ना, उससे पूछें कि TW1 गेटवे पर अगर ट्रैफिक 10% से ऊपर हो गया तो कितना बड़ा अलार्म बज जाता है।
हाँ
और
नहीं
ये बैकबोन कोर नेटवर्क जो है बहुत ज्यादा ओवर प्रोविजन होते हैं। ठीक है ना। इनके अंदर ट्रैफिक यूटिलाइजेशन जो है एक सर्टेन हद तक की जाती है। आपके एक्सेस नेटवर्क जो है, सारी बात है कि एक तो वो लो कैपेसिटी लिंक्स होते हैं और आपके यूजर्स से क्लोज होते हैं, तो वहां पर इतने ज्यादा ओवर प्रोविजन नहीं होते हैं। आपको देखें कि अभी अभी मैं आपसे बात कर रहा हूँ, तो जिटर क्यों आ रहा है, क्यों आ रहा है जिटर? ड्यू टू लेटेंसी। और अगर कोई मेरी मेरी वॉइस में जिटर आ रहा है, तो क्या ये बैकबोन को नेटवर्क का फॉल्ट है? उसका फॉल्ट नहीं है। ये सारा फॉल्ट, आपकी बात मुझ तक कट कट कर आ रही है, दैट्स ड्यू टू द एक्सेस प्रॉब्लम एट योर साइड, एट माय साइड। मैं वाईफाई मॉडेम यूज कर रहा हूँ, उसके बाद जो मेरा केबल नेट ऑपरेटर है, तो ये सारे अंडर प्रोविजन है। मेरे केबल नेट ऑपरेटर का इंटरेस्ट ये है कि वो पूरे इलाके में उसको फैला दे केबल नेटवर्क। ऑल दो उसके पास कैपेसिटी भी नहीं होगी, लेकिन वो क्या करेगा, पूरे इलाके में अपना वो चाहेगा कि कोई दूसरा आए नहीं, मैं ही फैला दूं सारा। उसके उसके जो स्विचेस हैं सपोर्ट भी नहीं करते होंगे। तो आपको देखें, इंपॉर्टेंस या स्टोकेस्टिक प्रोसेस की इंपॉर्टेंस कहाँ ज्यादा है, बैकबोन कोर में, एक्सेस में ज्यादा है?
जी सर, दोबारा बोलो।
आप आपको बताएं, आपने खुद कहा ना कि आपने एग्री किया कि एक्सेस
एक्सेस नेटवर्क
पर,
पे
ठीक है ना।
ट्रैफिक फ्लो कम होता है कंपैरेटिवली विद कोर।
कोर में असल में प्रोविजनिंग बहुत ज्यादा होती है। कोर के लिंक जो होते हैं ना, वो 100 ऑफ गिग्स के लिंक्स होते हैं, लेकिन उनकी जो यूटिलाइज, आप अपने किसी ट्रांसफर, मेरे एक दोस्त है ट्रांसफर में, सालिक उबीन, आप पूछें सालिक उबीन साहब से ट्रांसफर हाउस कि वहां पर जब भी ट्रैफिक 10% से ऊपर बढ़ता है, उनके लिए अलार्म होता है, इवन दो कि सिर्फ 90% ऑफ लिंक इज गोइंग अंडर यूटिलाइज। ये बैकबोन केबल्स में होता है कि दे आर वेरी वेरी हाईली प्रोविडेंट, बट लेकिन उनके ट्रैफिक लेवल जो है 10% या 15% से ऊपर नहीं जाने देते वो लोग। एक्सेस नेटवर्क में ट्रैफिक देखें, मैं एनआईटी के डेटा सेंटर चला रहा हूँ, तो वहां पर तो ट्रैफिक जा रहा होता है, 90% जा रहा होता है, क्योंकि वी हैव टू गिव सर्विस। ठीक है ना। तो ये चीज है। तो मेरा प्रोपोजिशन ये है कि एक्सेस नेटवर्क के अंदर इस चीज की इंपॉर्टेंस ज्यादा है, लेकिन अनफॉर्चुनेटली हमारे कॉर्पोरेट ऑफिस पे इंपॉर्टेंस, इस पर तवज्जो नहीं देते। ठीक है ना। हम सब डिपेंड कर रहे होते हैं फायरवॉल के ऊपर। हम लोग कभी भी अपने जो कि अपने ट्रैफिक प्रोफाइल पर गौर करते हैं, दे मॉडल देयर द And I think that this is more relevant to access site than backbone core network in your corporate offices. इसमें आप देखिए, अभी जब मैं इसके मॉडलिंग पढ़ाऊंगा तो आपको अच्छा आएगा। आप आपके लिए मेन देखिए, मेरा जो पेपर मैंने शेयर किया हुआ है ना वो पढ़िएगा, और पेपर आपके लिए उसमें डिस्कशन भी दिया हुआ है और मैंने बहुत ही लेमन लैंग्वेज में लिखा हुआ है। आप मेरे पेपर को पढ़िएगा, ये मैंने शेयर किया हुआ है, वही द रोल ऑफ वेबल डिस्ट्रीब्यूशन। उसमें मैंने काफी बातें की हुई है कि एक्सेस साइड पर क्या इशूज हैं, बैकबोन कोर साइड पर क्या इशूज। आप पढ़िएगा, आपको यू विल फाइंड माई पेपर वेरी इंटरेस्टिंग, और आपको काफी सारे सवाल का जवाब मिल जाएगा।
बिल्कुल सर, आप सही कह रहे हैं, ये पढ़ना पड़ेंगे डेफिनेटली। थोड़ा सा ओवरव्यू तो होगा इसका, क्योंकि ये एक आई थिंक ये रिफ्रेश भी करने की जरूरत है। मैं समझता हूँ ये ग्रेजुएट लेवल पे पढ़ा था कि सारी डिफरेंट
जी जी जी
और आई थिंक सारे यही एप्लीकेबल हो रहे हैं यहाँ पर।
जी। आप देखें ना, आप मेरे पेपर को देखें तो मैंने अपने पेपर में पूरी नेटवर्किंग अप्लाई की हुई है और पूरा सारा स्टैट्स मैंने अप्लाई करके को फोड़ दिया, इन सबका मल्टीप्लाई सब मैंने इसके अंदर डाला हुआ है। एवरीथिंग इज देयर। एंड देखिए, रिसर्च में क्या होता है, रिसर्च में हमें नीचे आना पड़ता है। वी कम टू द ग्राउंड रियलिटीज, और फिर वी कम बैक, वी एक्सट्रैक्ट द ट्रुथ फ्रॉम योर डाटा। जो डाटा के अंदर ट्रुथ है ये, तो इसलिए मैंने तो देखिए, रिसर्च नहीं है कि मैं बहुत ही हाई फाई मॉडल प्रपोज करूं। एक्चुअली ये मेरा पेपर जो पब्लिश हुआ है इतने हाई इम्पैक्ट जर्नल के अंदर, ये क्यों पब्लिश हुआ है? अगर मैं बहुत कम्प्लेक्स मॉडल प्रपोज करता तो कभी 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 पब्लिश नहीं होता। आई एम टेलिंग यू कि अगर मैं बहुत ही तो मेरा पेपर कभी एक्सेप्ट नहीं होता इस तरह के हाई प्रेफर्ड जर्नल के अंदर। और आप देख रहे हैं मेरे साथ को ऑथर्स कौन है, ये सारे न्यूजीलैंड के हैं। ये कभी भी दे विल नेवर लेट पब्लिश। ये है कि जो कि सिंपल चीजों को सिंपलीफाई करे। तो मैंने तो चीजों को सिंपलीफाई किया है। मैंने तो एक्सेस साइड, बैकबोन कोर साइड, पैकेट फ्लो सेशन सारे, और इनकमिंग आउटगोइंग ट्रैफिक को मल्टीप्लेक्सिंग पर देखा मैंने। आप मेरा पेपर पढ़िएगा तो आप, मैंने ट्रैफिक की मल्टीप्लेक्सिंग पर भी मैंने मॉडलिंग करी है, और ट्रैफिक के डिकम्पोजिशन पे भी, यानी कि जो इनकमिंग ट्रैफिक, बिकॉज इनकमिंग ट्रैफिक इज एक्चुअली डिकम्पोज ट्रैफिक एंड आउटगोइंग ट्रैफिक इज एक्चुअली सुपरपोज ट्रैफिक। जैसे मैं आपसे बात कर रहा हूँ तो मेरा ट्रैफिक जब बाहर जा रहा है तो इट इज सफरिंग सुपरपोजिशन। आपका रिप्लाई मेरे पास आ रहा है, आपकी बात मेरे पास आ रही है, तो दैट्स कमिंग फ्रॉम डिकम्पोजिशन। तो आप मेरे पेपर में देखें, मैंने सब चीजें बात की हुई है। तो यू विल, तो मेरा पेपर आप पढ़िएगा तो आई थिंक इट्स गुड दैट यू आर टेकिंग इंटरेस्ट। तो आप इंशाल्लाह पे बाकी के नेक्स्ट क्लास से जब मैं, बस मेरा एक मेन कंसर्न है कि अभी इस क्लास के अंदर ना, मैं अभी इसलिए मैं बहुत जल्दी नहीं मैथ पर आ गया क्योंकि मुझे लग रहा है कि क्लास में स्टूडेंट ज्यादा हैं, और मैथमेटिकल बैकग्राउंड आप सब भूल भूल चुके हो। जो पीडीएफ फंक्शन क्या होता है, डेंसिटी फंक्शन क्या होता है, व्हाट डू यू मीन बाय सीडीएफ पीडीएफ, ये सब आप लोग भूल चुके हो। तो चलें, ठीक है, थैंक यू वेरी मच। अब ये लेट्स मीट नेक्स्ट टाइम। मीनवाइल मैं आई विल कीप शेयरिंग सम बेसिक ट्यूटोरियल्स, ठीक है? थैंक यू। एनी अदर क्वेश्चन?
सर एक क्वेश्चन है,
जी
अगर
जी
हम जो रिसर्च अगर कर रहे हैं, जैसे रिसर्च अगर हम कंडक्ट कर रहे हैं, तो अगर
जी जी
हम एक मिसाल के तौर पे फाइबर लिंक का नेट है, सही है, और एक हमारे पास पीटीसीएल का नेट है। अब जितने भी यहाँ पे पाकिस्तान में सब्सक्राइबर्स हैं वो सारे पीटीसीएल के ज़्यादातर हैं, क्योंकि शुरू से चल रहा है, सबने वही लगाया हुआ है, एक मिसाल है जैसे। और हम
जी
फाइबर
जी
लिंक के ऊपर अगर आते हैं तो हमारे जो कंज्यूमर्स हैं वो कम है, सही है। तो
ठीक
अब
है।
अगर जो ट्रैफिक की हम बात कर रहे थे, जैसे ये रैंडमनेस और स्मूथनेस की बात कर रहे थे, तो जो अब मिसाल के तौर पे पबजी जो खेलते हैं या कोई ऐसा गेम है या कोई भी चीज़ है, वो पीटीसीएल पे ज़्यादा खेल रहे हैं, सही है। अब फाइबर लिंक वाला 100 MB का नेट लगाएगा या वो 200 MB का नेट लगाएगा, यानी जीबी तक के भी नेट आ रहे हैं, तो वो मतलब गेम खेलने के लिए तो नहीं लगाएगा, ज़ाहिर है, सही है ना। वो कोई मतलब प्रोडक्टिव काम करेगा या कोई डाउनलोडिंग और अपलोडिंग या सर्वर बेस्ड काम करेगा, सही है। तो इसमें फिर हम अगर दोनों का डेटा उठाते हैं तो उसके अंदर बिल्कुल डिफरेंट फर्क होगा, जाहिर है कि वो रैंडमनेस उसकी जो है वो बिल्कुल अलग है, और इसकी जो रैंडमनेस है
एप्लीकेशन
बिल्कुल।
डिपेंडेंसी आती है बिल्कुल ट्रैफिक के अंदर,
हाँ,
यही तो मैं कह रहा था कि एप्लीकेशन डिपेंडेंसी आती है। तो
अगर
हमें
हम, जी जी कहिए सर।
या आप बोले।
मैं ये कह रहा था, फिर हम यानी अगर एक मिसाल के तौर पे हम 10 ISPs को उठा के 10 डेटा कलेक्ट करते हैं, 10 रिसर्चेस कंडक्ट करते हैं, मिसाल है, और फिर उसको हम मतलब ओवर अराउंड द वर्ल्ड, मतलब कैसे, जैसे आपने वेरिएबल डिस्ट्रीब्यूशन का बताया, तो इज इट
हम्म।
एप्लीकेबल एवरीवेयर इन द वर्ल्ड, और या ये जैसे
देखिए, ये मुझसे सवाल ना ड्यूरिंग माय, देखिए पीएचडी में सबसे अहम मरहला क्या होता है, पीएचडी का डिफेंस डे। जिंदगी मौत का मसला होता है ना, आपको पता होगा कि जब बंदा 6 साल लगाता है तो जिंदगी मौत का मसला क्या होता है, डिफेंस डे होता है ना, पीएचडी
जी
पास या
सर।
फेल। ठीक है, तो ये ऐसे सवाल मुझसे उसमें भी हुए थे कि आपने ट्रैफिक पर काम किया है, न्यूजीलैंड का डाटा है, और मैंने बेसिकली न्यूजीलैंड का डाटा और यूएस डाटा पर काम किया था। तो वो मेरे एक एग्जाम में मेरे इसराइल के थे, तो वो फ्रैंको डेवोली साहब हैं, तो उन्होंने मुझसे सवाल यही ऐसे ऐसे सवाल किया कि व्हाट अबाउट कि अगर आपका टोपोलॉजी चेंज हो जाए और डाटा सेट चेंज हो गए, यूजर बिहेवियर चेंज हो जाए, तो आप खुद देखें, मैंने ये चीजें डिस्कस की थी अपने लेक्चर, अभी मैंने क्लास के अंदर आपको याद होगा कि मैंने बातें की थी कि टोपोलॉजी डिफरेंस। तो मेरा पेपर आप देखिएगा कि आई जो एंड में जो मैं लेक्चर को लेकर आया हूँ ना, मैं आप देखो कि मैंने लेक्चर के एंड में मैंने क्या बातें की हैं। मैंने बातें की हैं, सुपर पोजिशन की बातें की हैं और
जी जी जी
डिकम्पोजिंग बातें की हैं। तो मैंने
जी
इन चीजों से मैंने कॉम्बैट किया है कि मैंने लेवल ऑफ, जैसे मुझे उन्होंने कहा कि भाई कि अमेरिका में कुछ सिटीज में ट्रैफिक बहुत ज्यादा हो, चाइना में ट्रैफिक बहुत ज्यादा होता है, वो कहते हैं
बहुत
पॉपुलेशन
ज्यादा
ज्यादा है
होता
वहाँ पर, बहुत है ट्रैफिक है, ठीक है ना। तो वहां पर कैसे, तो मैंने तो जस्टिफाई किया कि मेरा काम तो ऐसे इलाकों में और वैलिड हो जाएगा, क्योंकि जो मैंने मल्टीप्लेक्सिंग एल्गोरिथम यूज किए हैं उनके एसिम्प्टोट जो है वो ज्यादा एप्लीकेबल हो जाएगा। जो जो मल्टीप्लेक्सिंग एल्गोरिथम मैंने यूज किए, मैंने कुछ रशियन ऑथर्स के थ्योरम यूज किए हैं। अगर आप देखिए मेरा थीसिस, मेरे वेबसाइट पर मेरा थीसिस दिया हुआ है, तो आप देखिएगा कि मैंने कुछ रशियंस के थीसिस यूज किए हैं जो कि एक्सट्रीम वैल्यू थ्योरी की मल्टीप्लेक्स में यूज किए हैं। तो जितना ज्यादा ये ट्रैफिक पॉपुलेशन दुनिया, और ये आपने खुद कहा पबजी और बाकी एप्लीकेशन जो टिकटॉक वगैरह, ऐसे एप्लीकेशन सोशल नेटवर्किंग की जो होती हैं, चाहे पीयर टू पीयर हो चाहे क्लाइंट सर्वर हो, एप्लीकेबिलिटी जो वेबल डिस्ट्रीब्यूशन है ये, कि मैंने इसके पीछे मैंने मैथमेटिकल थ्योरम्स यूज किए हुए हैं, एंड दीस आर एसिम्प्टोटिक थ्योरम। जैसे जैसे इंटरनेट ट्रैफिक बढ़ेगा, एक्यूरेसी ऑफ मैचिंग टू वेबल विल बी मोर एंड मोर। तो मैंने ऐसा काम किया है कि इट्स मोर, जैसे जैसे जो है ना, तो दैट्स व्हाई आई वाज अवॉर्डेड द डिग्री ऑफ पीएचडी, कि मैंने ऐसा थ्योरम प्रपोज किया है कि जिससे मेरा काम जो मे बी लेस रेलिवेंट है, किसी रीजन में मेरा काम अप्लाई नहीं हो रहा हो, लेकिन इट विल बी मोर एंड मोर रेलिवेंट एज ट्रैफिक
हाँ
इंक्रीजेस।
सही सही सही।
अच्छा सर,
नहीं है ना, तो
जी जी
आपका
बिल्कुल।
काम क्या होगा, टोपोलॉजी स्पेसिफिक होगा, ठीक है ना। अगर सिंपली आप जैसे बिग डेटा पे काम कर लोगे, तो जैसे मैं अभी कह रहा था, तो आपका काम बहुत ही, आप कंपेयर करोगे आईएसपीएस को, तो ये लोकलाइज काम करोगे, तो आपका काम जो होगा ना सिर्फली स्पेसिफिक टू योर टोपोलॉजी, स्पेसिफिक टू पाकिस्तान, स्पेसिफिक टू कराची, लाहौर, इस्लामाबाद।
ये मैं कह रहा था, मतलब यानी अगर हम स्पेसिफिक टू पाकिस्तान भी अगर रहे हैं जैसे, और फिर इसी का
हम्म,
डेटा उठा के जैसे न्यूजीलैंड का आप कह रहे हैं या यूएस का कह रहे हैं, तो
हम्म,
अब जैसे चाइना है, चाइना के अंदर वीचैट यूज होता है, यहाँ पे तो वीचैट पूरी दुनिया में कहीं यूज ही नहीं होता एक तरीके से, तो
जी जी
वहाँ के
बिल्कुल
बंदे तो वो जो डेटा है वो बिल्कुल ही अलग हो गया एक तरीके से, और
बिल्कुल
वहाँ
अलग
पे।
होगा। मुझे एम्बेसडर ऑफ
हाँ
चाइना ने मुझे फेलोशिप दी थी, ध्यान पे बीजिंग में रहा हूँ, मैंने भी यूज की है। तो लेकिन वही चीज ना कि अगर आपने यूनिफॉर्म ट्रैफिक मॉडलिंग फ्रेमवर्क बनाना है, तो
तो मैं
बिग डेटा
हाँ
वाले क्या
समझ गया।
करते हैं, बिग
हाँ
डेटा
वो
वाले
मैं
क्या कर रहे
समझ
होते
गया।
हैं, बिग डेटा वाले क्या करते
जी
हैं,
जी
डाटा उठाते हैं, मॉडल कर देते हैं, फिटनेस टेस्ट,
सही
फिटनेस
सही
अप्लाई
सही।
करके कर दिया। बिग डेटा वाले सारे ये करते हैं कि डाटा उठाया और मॉडल कर दिया और कहते हैं ये बेस्ट मॉडल, ये बेस्ट मॉडल फिट आ रहा है। लेकिन अगर आप अंडरलाइंग स्टोकेस्टिक प्रोसेस को समझ लेना आपने, देन आप किसी भी एरिया में चले जाएं। आपको इंटरनेट, आपने देखिए, ये बताओ, ह्यूमंस तो हर जगह एक जैसे है ना, ह्यूमंस तो एक्सेस थिंक टाइम
बिल्कुल
जो है
बिल्कुल
वो ऑलमोस्ट,
बिल्कुल।
पेज पेज का मैं बता रहा हूँ, पेज का थिंक टाइम डाटा इस ऑलमोस्ट, मैंने अखबार पढ़ रहा हूँ, कितनी देर में अखबार का वेब पेज करता हूँ, क्लिक करता हूँ, जो मेरा थिंक टाइम पैटर्न है, दैट्स हैव ग्रेट इम्पैक्ट ऑन इंटरनेट ट्रैफिक मॉडलिंग। तो मैंने ये चीज, इस पर भी मैंने काम किया हुआ है, अब मेरा एक और पेपर इस चीज पर भी है। तो आप देखिएगा कि ये इस दैट्स वो चीज यूज करो मॉडलिंग के लिए, कि जो कि जिसमें वेरिएंस कम हो, तो दैट विल लीड टू योर यूनिवर्सल ट्रैफिक मॉडल्स। आप मेरे काम को पढ़िएगा ना, आपको देखिए ये चीज बहुत, देखिए मैं ये सब बातें क्यों
नहीं नहीं, मैंने पढ़ा है सर थोड़ा भी, और पढ़ रहे हैं
डेवलप हो
इंशाल्लाह।
जाए इस कोर्स के अंदर।
नहीं नहीं, पढ़ा है मैंने, मैं अभी और इसको इंशाल्लाह पूरा पढ़ूंगा, एब्स्ट्रैक्ट और काफी पढ़ा था मैंने, कंक्लूजन वगैरह
हाँ नहीं, पेपर
इंशाल्लाह पूरा
देखिएगा तो
पढ़ूंगा।
यू विल गेट इंटरेस्ट, पैशन। वरना मैं बताऊं कि ये कोर्स अगर मैं डे वन से आ जाऊं ना, मैं ये खाली स्टैट्स प्रोबेबिलिटी पर, तो आप खाली बहुत बोरिंग हो जाओगे। तो मैं
हाँ
अभी
बोल
कोर्स की बेस, मैं बना रहा हूँ कोर्स की बेस बना।
थैंक यू सर।
थैंक यू, थैंक यू उमर, थैंक्स, थैंक्स।
नहीं सर, वाकई आपका जो आर्टिकल है बहुत स्कॉलरली आर्टिकल लग रहा है, काफी
हम्म,
डीप नॉलेज इन्वॉल्व है।
हम्म,
सर यहाँ ये पूछना चाहूंगा आपसे कि जो
जी जी
आपने टेबल डिस्ट्रीब्यूशन की डेटा फिटनेस और इसकी जो वैलिडेशन करी है, उसके लिए
जी
कौन सा टूल यूज किया था? और
जी।
दूसरा ये पूछना है आपसे कि जो वीबल डिस्ट्रीब्यूशन है, क्या ये हम रियल टाइम ट्रैफिक के ऊपर एज एन ऑन गोइंग जो है मॉनिटरिंग इसकी कर सकते हैं, या फिर इसको पीरियोडिकली डेटा सैंपल लेके उसको हम उससे हम फिर इंफरेंस निकालते हैं?
देखिए हमेशा आपका आखिरी क्वेश्चन जो है उसका जवाब मैं पहले दूंगा कि पीरियोडिक सैंपल देना जरूरी है, जितना देखें, जितना बड़ा आपका डाटा सेट होगा, उतना ज्यादा आपका जो फिटनेस की जो क्रेडिबिलिटी है ना, वो बढ़ेगी। क्योंकि फिटनेस एल्गोरिथम मैंने अपने भी प्रपोज किए हैं। मैंने कोलमोगोरोव, स्मिर्नॉफ केएस टेस्ट होता है, एक टेस्ट होता है एंडरसन डार्लिंग टेस्ट होता है, ये सब स्टैटिस्टिकल टेस्ट है, पढ़ाऊंगा आप लोगों को मैं। तो ये सारे टेस्ट होते हैं डाटा फिटनेस की बेस पर होते हैं सारे। तो ये इनके लिए होता है कि डाटा साइज ज्यादा होना चाहिए, लेकिन जो मैंने अप्रोचेस पेश पेश की उसमें यही है कि कम से कम डाटा पर आपका ये चल जाए। तो वेबल इतनी सिंपल डिस्ट्रीब्यूशन है कि कम से कम डाटा पर आपको बता देगी कि मैं मैच कर रही हूँ नहीं कर रही। तो इसलिए नियर रियल टाइम में चल जाएगा, जो यही मेरा प्रपोज्ड है, और यही मैंने वेरीफाई भी किया हुआ है। इसकी परफॉर्मेंस मैंने अपने थीसिस में शो की है कि रियल टाइम परफॉर्मेंस, और उस पर मैं और काम भी कर रहा हूँ उसके ऊपर ना, कि रियल टाइम परफॉर्मेंस ऑफ माई प्रपोज एस्टिमेटर कैसी है।
और सर टूल कौन सा यूज किया था आपने इसकी
टूल
सैम्पलिंग
तो
और डेटा?
मैंने सारा काम मैंने आर लैंग्वेज में किया है अपने। आर लैंग्वेज के अंदर, जैसे मैं खाली मैंने लिंक शेयर तो किया था मैंने आर स्टूडियो। आपके लिए स्टूडियो से यूज किया कि वो आपके लिए एज अ बिगिनर आपके लिए सही रहेगा। मैं सारा काम करता हूँ कमांड लाइन के ऊपर, तो आर लैंग्वेज जो है वो उसके लिए यूज होती है। आपके जितने भी स्टैटिस्टिकल मॉडलिंग टेक्निक्स होती हैं, आप इसमें आर में काम करो। मतलब आर के ट्यूटोरियल आपको बहुत सारे मिल जाएंगे, बहुत आर हैज ओवरटेकन मैटलैब। हम लोग मैटलैब पाकिस्तानी बहुत यूज करते हैं, लेकिन आर जो है ना, वो आर, मैं गया था इंपीरियल कॉलेज लंदन, तो
आपने यूज किया था
वहां पर लोग
ग्रेजुएशन
मजाक तो आर आर यूज करो, आर आर में मजा आएगा ना आपको, आर ओपन सोर्स भी है।
में?
तो आर में आप सारे काम कर लोगे। बाकी एक कि फिटनेस टेस्ट की बेस पर आपका एक क्वेश्चन बहुत इंटरेस्टिंग है क्योंकि ऑपरेटर्स आर वेरी मच इंटरेस्टेड के, क्योंकि हमारे रिसर्चर्स जो है ना, हम जैसे हम लोग हैं, हम लोग रिसर्चर्स ये कर रहे होते हैं कि हम लोग बहुत रिसर्च कर रहे होते हैं, लेकिन इन रियल टाइम में अप्लाई नहीं हो पाती है। ऑफलाइन डाटा पर हम लोग बहुत हीरो बनकर घूमते हैं, ठीक है ना, ऑफलाइन पर हम यार हीरो। लेकिन हीरो तो अब बनो ना जब रियल टाइम डाटा पर, जैसे आपका क्वेश्चन वैलिड है कि रियल टाइम डाटा पर वेरिएबल कितना फिट आएगा। हाँ, मेरे काम की वर्थ क्या है, मैंने जो सबसे बड़े मेरे काम की वर्थ है वो ये है कि मैंने लाइव डाटा पर मैंने काम किया हुआ है, यानी कि रियल ट्रैफिक मैंने कोई सिमुलेशन यूज नहीं करी। आई हैव नेवर डन ए सिमुलेशन, क्योंकि आप देखें 90% ऑफ द articles in internet traffic research is about the data analysis which is going inside a simulation। आपका एक टूल है, NS2 है या ऑपनेट है या ऑमनेट है, उसके अंदर आपने राउटर लगा दिए, आपने स्विच लगा दिए, और आप उसके अंदर डाटा जनरेट कर रहे हो, और फिर आके फिर उसके टूल के अंदर बैठ के काम कर रहे हो, और उससे डाटा निकाल रहे हो और उस पर काम कर रहे हो। तो ये चीज है। तो मैंने अपने काम के अंदर रियल डाटा लिया, मैंने रियल डाटा जो कि रियली चैलेंजिंग टू मॉडल। ठीक है, आप इसको मैं इंशाल्लाह, और यू विल गेट मोर एंड मोर इंटरेस्ट, तो इंशाल्लाह आप नेक्स्ट क्लास में आपको आई विल यू विल सी दिस। ओके,
थैंक यू सर।
थैंक यू। ये बाकी लोग क्लास लीव क्यों नहीं कर रहे भाई? स्टिल 11 पीपल।
नहीं वो सर सब सुन रहे ना, मजा आता है सुनने।
ये ऐसा लग रहा है ज्वाइन करके भूल गए। हमारे अंडरग्रेड के
करके
बच्चे
बैठे
पता क्या
हैं।
करते हैं, क्लास ज्वाइन करके भूल जाते हैं, वो लीव करके चले जाते हैं। मुझे लग रहा है सारी आवाम जो है ना, ये ज्वाइन करके घर डिनर कर रही है।
नहीं सर, मजा आ रहा
नहीं
था।
सर, सुन रहे थे सर आप।
नहीं सर, सुन
अच्छा, आप
रहे
सुन,
डिस्कशन सुन रहे थे।
अच्छा, थैंक यू वेरी मच।
बहुत ज्यादा मिल रही है।
चलिए, ये तो बहुत खुशी है। मैं समझा कि आप लोग लॉग इन करके घर चले, कहीं बाहर निकल गए चाय पीने के लिए।
सर एक चीज पूछनी थी कि सर
नहीं सर।
हम इसको आपके लेक्चर के अलावा सर बुक से जो आपने बुक्स बताई हैं उनको और आपके जो जर्नल है वो मतलब रीड कर लें और कुछ।
ये बताएं, आपने अब तक कितने जिसे कहते हैं इंटरनेशनल पेजेस से पढ़ा है आपने अब तक? मैंने न्यूजीलैंड से पीएचडी किया है। यू नो, आपको डिफरेंस फील हो रहा है लोकल पीएचडीज और
बहुत फर्क है सर।
यस सर,
डिफरेंस फील? देखिए,
बहुत ज्यादा फर्क
देयर इज अ बिग डिफरेंस।
देखिए, ये मैं आपको क्या दिखा रहा हूँ, परफॉर्मेंस मॉडलिंग ऑफ डिजाइन कंप्यूटर सिस्टम, पूरी क्यू थ्री की किताब है ये, ठीक है ना। एक और आई कैन टेल यू वन मोर थिंग, जितनी देखें हमने भी देखे 6 साल न्यूजीलैंड में, मैंने 40 ईयर्स मेरी एज हो चुकी है। एक और बुक है, बड़ी अच्छी बुक है ये सब पी चुके हैं हम लोग, बहुत बहुत दिमाग खाया इनके अंदर,
खत्म
बहुत
हो गई
ये
ना सर, ये तो
ये
इनका वक्त खत्म हो गया।
नहीं, देखिए स्टैट्स के अंदर ये बुक्स का है, ये हाइप्स आती रहती है, बिग डाटा, एआई। आप देखें एआई है, एआई पर कितने काम चल रहा है। व्हाट इज एक्चुअली
बहुत
एआई?
काम।
डीप लर्निंग, मशीन लर्निंग, बहुत काम चल रहा है ना एआई। आप मेरे जिन दिन एआई पढ़ी वो बताएंगे कि एआई के पीछे क्या है, सब स्टैट्स तो है,
यस सर,
सारा सारा
प्रोबेबिलिटी एंड
स्टोकेस्टिक प्रोसेस है,
स्टैट्स।
सारा डेटा मॉडलिंग के ऊपर ही सारा
सारा
काम है।
डाटा मॉडलिंग के सारे स्टोकेस्टिक प्रोसेस है, ठीक है ना। तो ये चीज जो है ना, ये हाइप्स, बिग डाटा और ये एआई, दिस नथिंग। मेन थिंग इज स्टोकेस्टिक प्रोसेसेस, ये आपकी स्टैट्स, स्टैट्स में नॉट नॉट कि मैं कोर्स कर रहा हूँ स्टोकेस्टिक प्रोसेस है, आपकी स्टैटिस्टिकल थ्योरी, आपकी अप्लाइड प्रोबेबिलिटी is useful in control engineering, is useful in bioinformatics. आज कित अभी आजकल मैं एक और पेपर पे काम कर रहा हूँ, that's about analysis of extreme temperatures on covid spread rate, जो कोविड आजकल जो फैल रहा है। तो मैंने एक पेपर अभी लिखा है जिस पर मैंने स्पेन का, इटली का और बहुत सारे कंट्रीज के मैंने डाटा फेच किया है मैंने, और मैंने उनके जो मेडिकल डाटा रिकॉर्ड थे, आजकल की वेबसाइट WHO की वेबसाइट्स पर आपको डाटा मिल भी जाएगा, एक्सेस फाइल में मिल जाएगा आपको। तो उस पर मैं काम कर रहा हूँ कि टेम्परेचर और नंबर ऑफ पेशेंट और नंबर ऑफ डेथ, इनमें क्या कोरिलेशन है। तो ये सब डाटा देखें, ये और आई एम गिविंग देम एन एक्चुअल स्टैटिस्टिकल अप्लाइड प्रोबेबिलिटी लुक, आई एम नॉट गिविंग देम बिग डाटा काइंड ऑफ थिंग और एआई बेस्ड थिंग। मैं मेरा सारा काम, आप देखें मेरा सारा काम बिल्कुल ही क्रूड लेवल के ऊपर है, कोर रिसर्च है मेरा काम। तो इस वजह से तो आई कैन गिव यू, आप कह रही ना बुक बताओ ये बताओ, आई कैन गिव यू मोर नॉलेज देन बुक्स। ये सब बुक्स मैंने पी ली है, बहुत दिमाग खाया है मैंने। हाँ ये चीज है कि किस बुक से क्या चीज अच्छी है वो मैं बता दूंगा। नॉर्मल टीचर्स क्या कर रहे होते हैं, वो आप स्लाइड चला दी, स्लाइड चला कर दी, ये काम मेरे लिए बहुत आसान है। मेरे पास आई हैव एक्सेस टू हंड्रेड ऑफ स्लाइड्स, मैं आपसे बातें कर रहा हूँ, इतनी बड़ी मेहनत करने की क्या जरूरत है। आई वॉन्ट यू ऑल टू लर्न। आप इस कोर्स के अंदर उसकी थीम समझ गए, देन यू कैन डू रिसर्च अलॉट। मेरा इस कोर्स को पढ़ाने में जिस तरह से आपको पढ़ा रहा हूँ, इसका बड़ा अच्छा फीडबैक रहा है। मेरे स्टूडेंट ने मुझसे पढ़कर पेपर पब्लिश किए हैं इसमें, क्योंकि ना तो मैंने कोई बुक बताई है ना, दे 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 ट्राई टू गॉट माय थ्योरी, द वे ऑफ माय टीचिंग, the way I emphasize certain points, they got this and then they take this and then read the books, और फिर उस पे से रिसर्च करते हैं, डाटा पकड़ते हैं, और क्योंकि इससे पढ़ते पढ़ने से कुछ नहीं होता, डाटा पकड़ो एंड सी द डाटा, उसको प्लॉट करो में डालो, उस डाटा को प्लॉट करो एंड देन उसको जूम इन करो, उस डाटा का टाइम स्केल चेंज करो, स्केल फैक्टर चेंज करो, देन ये इस चीज सीखते हो। पढ़ कर पढ़ते रहोगे पढ़ते रहोगे पढ़ते रहोगे, कुछ नहीं मिलेगा आपको। यू हैव टू वर्क ऑन डाटा योरसेल्फ एंड देन सी। हाँ अब चेक करो कौन सी डिसिप्लिन फिट आ रही है, कितना वेरिएंस है डाटा के अंदर, कितना कर्टोसिस है, कितना स्क्यूनेस है डाटा के अंदर, ये चीजें आपको पता होनी चाहिए, देन यू विल लर्न अ लॉट। ठीक है। अच्छा मैं यूनिवर्सिटी से मैं आया हूँ 6 बजे, और 6 बजे आते खाना खाना खाने देंगे आप लोग, मुझे नहीं खाने देंगे?
जी
जी
खाइए
जी
सर,
खा
बस
लीजिए
सही है
सर।
सर, थैंक यू सर।
थैंक यू, खाइए
हो
आप।
गया हो गया, अल्लाह
चले
हाफिज।
सही, थैंक यू, थैंक यू। बच्चे बाहर चला रहे हैं सर,
Sunny sir,
थैंक यू,
nice
अल्लाह
talking
हाफिज।
to you, and I must appreciate the way you are teaching, sir.
थैंक नहीं
Definitely.
नहीं, आई रियली वांट यू टू इंटरेक्ट, ठीक है ना, ये यही तो मैं चाहता हूँ कि बड़ी बड़ी खुशी हो रही है कि आप लोग मुझसे इंटरेक्ट कर रहे हो। आप लोग भले अभी 9:30 बज रहे हैं, आप लोग मुझसे रात को 12 बजे बात करो, मैं बात करूंगा, लेकिन ये चीज है कि और क्लासों में मुझे नहीं मिल रही। अंडर में बच्चे, आई लुक लाइक वन वे, अंडर में लग रहा है मैं वन वे पढ़ा रहा हूँ, वन वे, नो रिस्पॉन्स कम्स। यहाँ पर एक खुशी हो रही है मुझे कि चले आपका बैकग्राउंड है कि नहीं, यू आर कमिंग, हालांकि इस क्लास को पढ़ाना मुश्किल है क्योंकि इसमें डाइवर्स बैकग्राउंड के लोग बैठे हुए हैं, लेकिन आई एम वेरी हैप्पी कि आप लोग मुझसे बात कर रहे हो मुझसे, देन दिस विल मेक मी मोर कॉन्फिडेंट इन टीचिंग। आपको क्या पढ़ाना है क्या नहीं पढ़ाना, दैट विल मेक मी मोर टीच, क्योंकि आप फीडबैक दे रहे हो, मुझसे बात करो। और यही बिहेवियर जैसे अभी आप मुझसे क्लास की बात कर रहे हो, ड्यूरिंग द क्लास मुझसे बात किया करो, मुझसे ड्यूरिंग द क्लास मुझसे पूछो ये चीज ऐसी है, ये आप गलत बोल रहे हैं, ये चीज सही बोल रहे हैं, ये चीज ज्यादा इंटरेस्टिंग है, इस तरह से बात करो। डोंट बी लाइक अंडरग्रेड, अंडरग्रेड मुझे लग रहा है कि मैं बस स्पीकिंग वन वे, वो वहां से जवाब ही नहीं आता, बच्चे हमारे लॉगिन करके चले आते हैं घर। मतलब अंडरग्रेड में आपको पता है तफरी चल रही है, मुझे मुझे बिल्कुल मजा नहीं आ रहा अंडरग्रेड पढ़ाने में, कि बच्चे जो है ना बड़ी तफरियां करते हैं, वो बस क्लास स्टार्ट करी और उसके बाद म्यूट करके गई,
कहीं चले गए।
नो सीरियसनेस इन अंडरग्रेड। पीएचडी अंडरग्रेड में तो मैं पढ़ा, लेकिन चूंकि हमारी ड्यूटी है, मैं पढ़ाना होता है और उनका राइट भी है, आई ट्राई टू माय बेस्ट टू गिव मोर नॉलेज टू अंडरग्रेड स्टूडेंट्स एंड दे शुड। लेकिन आजकल ना अंडरग्रेड लेवल पर इतना बच्चे अप्रिशिएट नहीं करते पीएचडी को, उनको बस एक टीचर जो कि नंबर दे दे उनको बस।
सर असल में बाकी सारे टीचर्स भी तो फिर वो है ना इशू, हम लोग क्योंकि खुद अंडरग्रेड से पढ़ के आ रहे हैं, तो हमारा सब मेरा अपना तो बाकी को नहीं मुझे पता, मेरा अपना
जो
यही होता है कि अभी जैसे हमें दूसरे भी सर्वर मिले हैं, तो सर्च का भी सर बड़ा इशू है, जिसकी वजह से फिर इंस्टीट्यूशनलाइजेशन हो जाती है ना स्टूडेंट्स की, ये भी
जी
तो
जी
इशू
हाँ,
है।
यू आर राइट, यू आर राइट, बस स्टिल चलें, थैंक यू वेरी मच, इंशाल्लाह
थैंक यू
नेक्स्ट वीक
सर,
दोबारा मिलते हैं, ठीक है ना, थैंक यू,
थैंक यू सर,
थैंक्स थैंक्स।
अल्लाह हाफिज़।
थैंक यू सर, अल्लाह हाफिज।
सर